Today, we're going to do something different today. We're going to go back with RC, but we're going to be doing we're going to be here for 5 hours. So I wanted to show you the new schedule change. This is something that's going to happen going forward, kind of like forever. So, I mean, you don't need to see my personal stuff and my birthdays, but we're going to be doing streaming. The only streams you're going to find on the schedule, and to get the schedule is, twitch.tv or rwxrob.tv/schedule. I'm going back to using the Twitch schedule for everything. If you come in here, you'll be able to see it, and it'll show the stuff coming up. So you'll see that we have, it's a little bit harder to read than the Google Calendar. We have Head for C today, and we have just regular chatting. So why do you need to know this? Because going forward, there's going to be 5 hours, 45 minutes with a 15-minute break every hour. We're probably going to take a 15-minute break. I'm going to try to keep to that schedule. It probably will be more like a 10-minute break. And during the breaks, by the way, you can ask questions and stuff like that. Either of me or the Discord. You can ask questions anytime, but during the first 45 minutes, I'm going to be doing something. I'm going to actually write something up about the breakdown of that time. So this is, you can consider this kind of like 5 sessions in one that are all combined. I'll be putting bookmarks in the video, but it'll be one video as opposed to lots of videos. People have said that they prefer that, so that'll also all go up on YouTube. And we're going to try to get through C. So here's the calendar. Come on, baby. Calendar. Here's the calendar we have planned for now. We're going to end C, Head for C, whether or not we finish the book. We're going to be finishing the C series on February the 5th, and we'll be going forward. So that's, that gives us what today, 2, 3, 4. It's like 3 or 4. We're going to be cramming through the book really fast. We're going to be going. We have 5 hours a day though, so we should be able to do it. If we can't, that's fine. You can go through the book on your own and finish it. I do need to accelerate this because I need to finish up these last 2 segments for the year. Our years rotate on May the 4th, so May the 4th is a beginner boost. We're getting ready for that, and then we do get the gig or good to gig after that, and then we're going to do something new. We're going to be doing infrastructure, where we talk about how to install Linux, how to run virtual machines, how to do Ansible, Terraform, that kind of thing. Networking, a little bit more depth. And then we'll be going into, we're going to have a security analyst boost, which is just basic Unix things. And then we'll do our head first boost every year at Christmas time. And then we'll be back around. So this is going to be the rotation as it go in EXE. So this is the rotation. I've been telling people about it, but I wanted to put it at the beginning of this video because this is going to go up on YouTube so that you can just be aware of the changes going forward. I know it's aggressive, but this is what we're trying to do. Again, there's no cost for anything, but I certainly appreciate the votes of confidence. I got somebody gifted 25,000 bits the other day, and I got another like $20 sponsor on GitHub. So people are actually showing their support for what we're doing, and I really appreciate it. Let's go back. A lot of there's been actually talk of starting a company from some of the people that hang out. We have pretty substantial people. We have over a dozen people that make over 400,000 a year as CTOs and executives and board members and consultants to the White House and something like that. We've joked about creating our own company just from this community and hiring all the people that we train here. So who knows? Who knows what we're gonna do? I can't say anything about that, but something might happen. Something might along those lines. I've always wanted to do that, by the way. So to have the kind of people that have this level of knowledge combined. So let's get back to where we need to be. Head for C projects, and we are on chapter 2.5. So I'm actually going to make a new chapter for that because they did as well. Chapter 02.5. Let's just put it in chapter 2. If you're confused because I already did a video about this, it's because the last video I did, the 2.5 video, was pretty much just ready to throw away. I rabbit hole too much down some other stuff. I need to make it more succinct. So we're going to redo chapter 2.5. Only this time I'm going to stick to the book as much as I can. And we got into the dangers of C and bounds checking and all of that kind of thing. And it really went crazy. How's it going? Good month. Good math. So let's do that. We have to watch the timer, which right now is 11. I don't have a timer set right now, but we have 11:16. So we're going to go for half an hour. So let's see if we can get the rest of 2.5 done in this first time frame. Twitch descriptions. Does it not post? Does it not point to it anymore? It should. If it doesn't, I don't know. Which one does it point to? If it doesn't point to that one, then I'll go fix it. It points to YouTube. Ouch. Okay. Yeah, I'll make a note of that. Thank you. Yeah, I won't do it right now. We're doing this, but thank you for pointing that out. If you see something like that, let me know. Also, Discord is the thing. So, you're going to need to know about Discord. Just to ask questions off topic. I mean, off stream. I don't stream all the time like I used to, so it's the best place to go if you want to ask specific questions. I have a topics category that you can ask specific topical questions. It'll stay around if you don't want to just there's a main chat channel if you just want to do general chat, which is totally fine. Anything goes in there too, by the way, as long as you don't, abuse it. All right, so enough orientation. We have 30 minutes to cover the rest of this. So let's do that. Let's do PDF, head for C. To get head for C, you might have to, I purchased mine. We talked about that again. No, I'm not going to go over that again. Go back and watch the first boost about the book if you want to use it. This is the book we're going to use. All right, so it's 2.5. So chapter 2 was all about pointers, and we did it very, very slowly. And then came 2.5. A lot of the time we were talking about the dangers of reading off the end of a pointer. Off the end of a string, right? And the difference between a string array and an actual string, and what's a string literal, and all of that, right? And we got some things wrong, and we came back and corrected it through validation through the community. And you got to be careful. You should really not trust any book. I don't care how good the book is. The books are wrong. We actually found a pretty substantial errata entry that we spent like 30 minutes on trying to figure out. So, take it with a grain of salt. If something doesn't feel right, maybe this is why you should have a mentor, right? So you have a mentor. What is a mentor? A mentor is somebody who's in the field. It's not an academic or a theoretician or a hobbyist. It's somebody who does that thing that you want to learn regularly, either as a profession or as a regular occupation of some kind. Anybody else is not a mentor. You can't have a mentor unless they have done it. Yeah. So here we go. We're going to go back to, we're going to go back here. Yeah. And CD into chapter 2. And let's look. All right. So, wait, where's our PDF? All right, here we go. We're already there. All right. Again, if you have questions about how I'm doing what I'm doing, a lot of it's covered during the boost, which I gave you. If you want to watch the old boost, like how to use the terminal and everything, that is the core topic of the beginner boost. But again, I'm happy to try to answer a question really quick right here. The chat really knows a lot about this too. All right, so just be aware also that anything you do chat on screen will appear in the video. If you don't want something to appear in chat, as I said in my about, just put an exclamation point in front of it. You can only participate on Twitch or IRC plus Twitch. I have 2 videos that I talk about in my about called "Switch Without the Twitch" if you don't particularly want to use the web thing. So here we go. Let's come back to string theory. So 2.5, it turns out, is all about manipulating strings safely using the strings library, strings.h. And we're going to jump in. String CMP says, we're identical. I thought I called you short and said your butt was bigger. Lol. There's more to strings than reading them. You've seen how strings in C are usually char arrays, but what does C do to allow them? Well, That's where string.h comes in. String.h is part of the C standard library that's dedicated to string manipulation. If you want to concatenate strings together, copy one to another, or compare two strings, the function of strings are here to help. In this chapter, you'll see how to create an array of strings and then take a close look at how to search for strings in this and the string subfunction, which is a function that finds a substring within another string, one string inside of another string. Now, I'm going to take a moment here. I don't remember the book talking about this at all, and it's really, really super important. By default, C strings are ASCII text. And what do I mean by that? So you've probably seen, what is ASCII text? You can go do a search for this. ASCII, abbreviated from the American Standard Code of Information Interchange, is a character encoding standard for electronic communication. ASCII code represents characters in computer, blah, blah, blah. Bottom line, ASCII is mostly English romanized characters. No Unicode, no emojis, no kanji, none of that. Okay? So this is probably the biggest failing of all of C for modern applications development. Now, to be fair, as we said, C is used because it's close to the hardware, and people don't give a shit about Unicode when they're dealing with things close to the hardware. Very rarely do they even have to use any form of communication other than error messages. So somebody pointed this out last time, not the Unicode thing, but they pointed out that these books and all of these tutorials and stuff that have you interacting with the command line, you know, and writing a REPL and printing and all that stuff, that is very rare for most C development. People don't write C applications that interact with the user a lot. That's not its best place. I mean, most of that kind of stuff is usually, you know, given to another sort of language. C is designed for getting humans to be able to talk to the hardware, usually, or to be very, very high performance. And that's so important. That's so important because, you know, and if you think of it that way, the fact that the characters and the whole strings.h only deals with ASCII characters, it's not as bad because most applications have kind of taken on an international standard for putting their errors in English anyway. But I think it's super important to say that. Now, in contrast, I'm going to plug my favorite language again, my favorite compiled language. So we have another language that's called Go, and Go was actually created by two of the people who were the primary people behind the current Unicode's design international standard, Rob Pike and Ken Thompson. And they also, you know, created operating systems and contributed partially to C with Ritchie and stuff. I mean, these are big names in the computer world. Their design skills are legendary when it comes to this kind of thing. So all of the stuff that we're going to talk about when we talk about iterating over strings and going through each character, everything like that, ranging and all that, those kind of things are all character specific. And as we'll see, a single character is a single byte length. And that's a problem because Unicode characters are multiple bytes. Up to let's see, unsigned int32. So what is that? 32 bits or 8 bytes? 4 bytes, sorry. So the point I'm trying to make here is all of this entire chapter about strings, this entire chapter that we're going to be talking about with strings is pretty much irrelevant when it comes to user applications. You would never pick C for a modern interact with the user application, prompt them for questions and things like that. You never ever pick C today. Not unless you had a very substantial library to deal with the Unicode. This is one of the main reasons that Go was made. Because Go needed it. It's also one of the main reasons Python 3 was made. Python 2 wasn't aware of Unicode. We're doing C. Yep. So what I'm going to talk about, so we're actually making a YouTube video right now. I have to say that again. We're making a YouTube video for the next 5 hours. You're welcome to ask questions and stuff, but we're following the Head for C book. You can go watch the first video on YouTube if you want to get caught up. Just to know, you know, what we're doing. See the docs, the terminal. Do I use something to reproduce these docs? We're talking about this thing in the terminal. That's all answered in the boost. So I'm going to say it again. If you're brand new and you want to know how I do everything, it's all in the boost. It might be good for you to go watch that instead of the C thing. But we like to have you here either way. Okay. So I'm gonna end on that point about ANSI. Okay. So C, the C strings library uses ASCII characters, and let me give you a sense of those. Okay. So here are the ASCII characters that we use. There's a video on that too. Yeah. But I suggest use W3. So yeah, if you want to do that stuff, go on. And by the way, there's a 3-hour AMA session tomorrow at 11. So if you want me to answer those questions more fully, tomorrow's the day. Okay. So let's see, PDP monitor, Unix conventions. All right. So here we go. So this is kind of a fast version of this. Let me show you the graphical version of it. Right. So here is the original C character chart. The thing is crazy is like the number 1, 2, and all that kind of thing. So the exclamation point is actually character number 1, 001. So you see how ASCII actually doesn't even use a full byte, it uses half a byte. It was extended ASCII that used a full byte. In other words, 7 bits. They lift off the one of the bits for the signing, which was unused as significant bit. So that none of that stuff is covered in the book, and I really feel like we need to talk about that. You really need to know ASCII. During our other programming classes, we're going to cover that a lot. So that'll be a thing. All right. So let's go back to what we were doing. Let me think here. Yeah. Okay. So go back to the book. Again, we're reading Head for C. You can get it on GitHub for free, or you can buy it. I bought mine. If you want to add 2 strings together, blah, blah, blah. Desperately seeking Frank, lol. Okay, so they have these kitschy things to help you remember as a part of your kind of your active recall, have memory association. There are so many tracks on the retro jukebox that people can't find the music they're looking for. To help the customers, the guys in the Head First Lounge want you to write another program. This is the track list. Okay, so they want you to put all these tracks into a program. All right. So Wayne Newton again, we did a search program to help people find tracks. They want you to be able to search through all the tracks. It does if you don't put an exclamation when you reply. It doesn't. No, I'm sorry. I wish it did. I don't have a choice. They screwed that up. The list is likely to get longer, so there's just a few tracks for now. You'll need to write a C program that will ask the user which track she's looking for, they are looking for, we'll say, and if get search through all that blah. So we can actually go jump right into this. And it says brain power. This is where I got diverted last time. I said, okay, fine, I'm going to write the whole thing myself, just thinking about it. There'll be lots of strings in this program. How do you think you can record that information in C? So let's actually take a moment. Let's try this, right? So if you have a computer right now and you're all set up and you're following along, go get on your terminal and let's write, first of all, how would we make a list of all these things? Let's go figure that out. Let's figure that out, okay? Is this Jimmy? Or is it tracks? It's tracks. All right, so I'm going to go into tracks. Get status. Untracked files. Okay, so I actually already sort of finished this one. So I'm going to move it to tracks.old. And we'll do that. We're going to do it again. I'm sorry, because the other one was like way too painful. So how do you start it? Well, first of all, you make a make file. Say I want to build tracks this just says build tracks. And there's implicit rules that say if anytime you have a .c file, build an object file out of it. So we're going to do that. So that way you can just make a tracks file and then it will make the other one. So include tracks. stud.io.h. We do all that all the time. We're going to do int main and return 0. And there's our beginning program, right? And I don't know, put us, uh, uh, we, we will prompt for tracks just to test everything. Put s adds a line return, so I can make that and run it tracks, and it will just run. We will prompt for tracks. Okay. So what do we need to make here? Let's look at the requirements. It says this list is likely to get longer, so there's just a few tracks there. So there's just the first few for now. You'll need to write a C program that will ask the user for the tracks and get the search, and then search through all the tracks. How do you think they can record this information? Let's see. How can we, so we know about strings, right? So we know these have to be strings. So let's go ahead and make, let's start by just building our first variable. So if I were just going to do one track, what would it be? It would be a char, it'd be a pointer array, right? Now we've done this a couple different ways. We've done it like this. We could say track 1, right, and make it a character array. We know we can do it that way. I left my heart, fuck that. Actually, I'm going to steal some of the tracks from my old one because they were much more fun. We were listening to 80s music while we were doing this last time. All right. Don't look. It's cheating. All right. So let's put that one in. What have I done to deserve this? This is an 8. So that's a character array, right? Now, we could have done it like this too. Let's do track 2 the other way. Kiss them for me. Bum, 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 bum. That's a great song. All right, so there's another one, right? Now, but what if we did this instead? What's the difference? You guys remember? Does everybody remember the difference between these two? What is the difference? What is the difference between those two? Take a moment to make sure you understand the difference between those two. They're both usable. We can make a program out of both of them. But one of them has a specific difference. And we spent like hours going over this last time. So if you don't know the difference between these two things, do not proceed. Go back to not to go, but to last week at least, and make sure you do. This gives us a pointer. So the thing that actually gets written into track 2 is a number. It's a memory address, a pointer to Kiss Them For Me, which is saved in the strings literal section of memory. Just to recap, it gets saved to, the first is immutable, yeah. It gets saved to here, okay? It gets saved, it's not a constant, it's a global, it gets saved down here, but still, actually it's a character array, so it gets saved down here, and then a pointer, the pointer to where that exists in the constant section is what you get, okay? In this one. This one, yeah, if you wanted to, you could make it a constant like that, and then it's even better. We talked about that. The book doesn't talk about that, but that is the better way to do this, because it's actually, if you're going to do this, you need to do it like this. If you're going to do a constant, that says it's the pointer that's never going to change, pointing to a thing that's never going to change. And if you write it like that, then it won't surprise you at compile time. Otherwise, you could be surprised. But it's more common to just have people do this because they don't plan on messing around with the pointer. This says it's a pointer to a constant, right? And the reason for that is so if you try to change it, it'll blow up at runtime if you do, unless you put the constant, then it won't even compile if you tried it. So that's probably the way to go there. So this one actually gives you track. What gets put in track? The address of a copy of this string literal, which gets written to the constants. And it can be changed. It can be changed. We showed that at great length last time. So that actually can be changed. So do we want to be able to change ours or not? Now the book, I happen to know the book is going to use these by default, which I think is dumb, because these are things that aren't going to change. They're going to stay, right? So let's change this one. Make it a const char. All right, well, here's something. Track 1. So now we have track 1 and 2. Now, wouldn't it be great if we could put those in a list, right? So this is where things get kind of interesting. And you can probably figure it out. We need to have an array, right? So how could we rewrite that? We learned a little bit about arrays. Arrays are just groupings of things, right? So we could say, I want a bunch of pointers, right? Now I know that the book doesn't do that way, and for the sake of consistency with the book, I'm going to drop the pointers for now, and we're going to use the modifiable character arrays, because this is going to make more sense as an array. So now we could say I have an array of arrays. So we can say tracks, right? We have a tracks array. That tells us we have an array of whatever size. We have a tracks array, but what is it an array of? Well, it's an array of pointers. It's an array of characters. I have it. We can. Yeah, that's a good question for tomorrow. So we're gonna get there. I want to take you through the book on this, but we're going to start with character arrays and use it this way just for now because the book does. But I like to use the pointer method, and we'll get to why in a second. So let's go back to the book, because I don't want to divert too much from the book this time. So create an array of arrays. There are several name tracks that you need to record. You can record several things at once in an array. But remember, each string is itself an array. So this says, so character tracks, the first set of brackets is an array of all the strings. And the second one is how much space you can put in each string. Now, what they didn't tell us, this is something that's kind of, they didn't tell us, well, how long can it be? How long are my tracks, right? So let's break it down. So we have an array of arrays like this, and we know that the longest one is 80. It says the second set of brackets is used for each individual string. So we have an array of character arrays. You know that the track names will never get longer than 79 characters to set the value to 80. Why 79 and 80? Because of the null, remember, the null at the end. The compiler can tell that you have 5 strings, so you don't need to remember between these brackets. In other words, in here you don't need to put anything, because it can infer that just like you could in the character array before. This number, however, is the maximum size for any one entry in here. Each string is an array, so this is an array of arrays. And the array of arrays looks something like this in memory. So there's your first one, and the next one, and the next one. Each song title will allocate 80 characters. Okay, so 80 characters, that includes the null. And then you have the tracks that goes down. Tracks 4 is down here. Tracks 4, 6. So this is the letter R. This is the 4th track, 1, 2, 3, 4, and it's 6 over, 6 column. 1, 2, 3, 4, 5, actually 0, 1, 2, 3, 4, 5, 6. So that's how you get that specific letter. So you can see where they're going with this. This means that you can be able to find an individual track name like this. I want track 4. This has a value. So track 4 points to what, by the way? Tracks 4 points to the first letter of this thing. And then it says, okay, well, how far over do I go? This is the 5th string. Remember, it's always begin with 0, 0, 1, 2, 3, 4, 5. But you also need to read the individual characters of those strings if you want to. So if you want to, you can read that. So now you know how to record the data and see what do you need to do with it. All right, so let's go ahead and put that together in C. I've already written that, so I don't want to waste time writing it. Tracks old. So you can take some time to write it. And I deliberately put in my group of stuff that's going to break. Okay. Because why? Wait. Yeah. So I put some stuff that's going to break. This down here, right? This has emojis in it and some Russian characters. Okay, so I put that in there on purpose so you can see that this does not work. This does not work with Unicode. This will break. It'll be fine. It'll try to search it. It just won't find anything. If you try to search for the emoji, it won't find it. Change it to WHRT work? Possibly. Possibly. But that might be a rabbit hole, a side quest that we can do. It's not in the book, but that's definitely a side quest. So there's our array. We've got that done. Now let's go down to the next page. First strings contain the search text. The guys have helpfully given you the spec. So this is a spec. What is a spec? A spec is a specification. That's the list of requirements. This is also how we do learning, by the way. So when we create open credential merit system credentials, Occam's credentials, we call them, we list out all the requirements that are necessary in terms of what you would see in a job posting, like use Unicode in a string in C or something like that. And then, but that's kind of what you get on a project too. You get the specifications of what is required, a list of requirements usually, and then what are the criteria to say you fulfilled it. It's a really regular part of software design and IT in general, so I like that they are using the term. Ask the user for the full text she's looking for. We're going to use they for that. Loop through all of the track names. If a track name contains a search, display the track name. So we're going to do what's called a linear search through all of it. It's the slowest search method. If you do any computer science and data structures and algorithms, you're going to go through all of this. And in C, data structures and algorithms, particularly the algorithms, they matter because that stuff has not, in C, there are libraries for it all. You would never, today, if you're going to write, production software, you would never write your own, bubble sort or whatever. But you need to understand how C does it better than anywhere else because all the other languages have it built in. Define nil void, right? Yes. Okay, so here we go. We're gonna do. They've got to spec. Well, you know how to record the tracks, so now you need to know how to loop through them. You even know how to ask user for a piece of text. But how do you look to see if the track name contains a given piece of text? Enter strings.h. And the mistake I made last time was trying to do this without strings.h. It's actually very dangerous and scary and hard. And if you want to, go back and watch the VOD on Twitch before it gets deleted, you can. But I don't want to run you down that rabbit hole into the wall. Whatever, mix my metaphor. The C standard library is a bunch of useful code that can help you get when you install the C library. Library code does useful stuff like opening files, doing math, or managing memory. Now, chances are you won't want to use the whole thing, so the library is broken up into several sections, and each one has a header file. The header file lists all of the. We ended up writing our own string. I tried to write my own string function. There's actually a competition to see who can make the best ones. But we're just gonna actually use string. I'm kind of jumping ahead. The string is a function that tells you if a string contains a substring. So it's exactly what we want. It already does the search for us. It's what you tend to make your own stuff. Yeah. Now chances are you won't want to use the whole of the standard library at once. That's what goes in the header file. That's why we use std.io. The header file lists all the functions that live in a particular section of the library. So far, you have only used one, stdio.h. Stdio lets you use the standard input-output library, printf, putf, scanf, all that. But the standard library also contains code for processing strings, and that's strings.h. Yeah. Okay, yes. So here we go. Compare two strings to each other. Make a copy of the string, search for the string, slice the string into pieces. These are all things you get in the toolbox with string.h. It's actually strings. Is it string or string? I always forget that. I always forget that. It's string.h. Okay. You include the string in your program by using include string.h. All right, so let's do that. We know we're going to need to do that, so just copy this one, change this to string.h. Actually, just change this to string. All right, save it and go down. All right, what's my purpose? See if you can match up the string.h function with the description of what it does. Oops, we're getting close here. We'll go for another 5 minutes. So after this, we're going to take a 15-minute break. You can ask questions and stuff, and I'll put a marker. String CHR, string CMP. Let's see, concatenate two strings. Let's see. Does anything say cat? Yes. There's concatenate. That means join two strings. String lang. Let's see. Find the location of the string inside another string. Ooh, maybe this one, string. Yep. Find the location of a character inside a string. What? A character inside of a string. Ooh, it must be this one, string character. Find the length of a string. That's easily string length. Compare two strings. String CMP. String CMP. Copy one string to another. Shocking string copy. So I think the important thing to take away from this is there are libraries and they do the hard stuff. Like Ancient was talking about, there's a library that gives you wchar_t, which is for Unicode. And there are, many other, libraries for iterating. There's just libraries for pretty much everything. And you're going to be writing your own libraries eventually. So learning how to use a library is the first step towards doing that. So sharpen your pencil. Here's the actual answers. Okay, we got that right. And we're going to use the string function. So this is next. We'll do this next. I'll leave this on the screen so you can read it. However, we are going to take a break. So we will be back at we're back at the top of the hour. So we're going to be back at noon. So actually no. I'm going to take that back. Let's actually work. Let's do this. Let's work till the top of the hour and let's take 15 minutes at the top of the hour. How about that? You want to do that instead? You know why that's better? Goodbye, Binus. Like the head first books are really great because they do tap into your mnemonic devices and methods of memorization. I take it back. I'm going to keep working. So just stay here. You know why? Because we need to do the breaks at the top of the hour. And the reason for that is because when we start, people always want to talk and chat and everything, so we lose the first 15 minutes. So let's always start our break at the top of the hour, and that way we'll always know at the top of the hour it's time to take a break. Okay? So using this string function. So how exactly does the string function work? Let's look at an example. Let's say you're looking for string fun inside of another one. String dysfunctional, and it looks for fun. String will go ding, 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 ding. Do I have an F? Yes. Okay, do I have an U and N? You can write that algorithm. If you want to, you can go look, just do a search for string, str, algorithms or implementations on the internet, and you'll see a bunch of amazing ones. We actually have a not so successful attempt at that very thing that I wrote last time, because this is kind of what it would have to do. You'd have to iterate over the length of all the tracks and then iterate over it doesn't have it and what's the state. It's not even close to being done. But the point is, if you want a side quest, write your own string function. You should know how to do it. We did loops already. We did, state, we did character variables and stuff. You can write your own. And if you want to have an exercise in, it's kind of a LeetCode code sort of thing, write your own hyper optimized iteration through this to figure out how you would code this. If you didn't have the library, how would you code it? And that's what C is good at doing. So you should, and let me give you a hint. Make sure you consider that pointers themselves are numbers that can be iterated through, and that a pointer can be a false condition when it's null. Those are some tricks that you can use. And if you want to do that, that's kind of a bonus test, a side quest if you want to do it. It's pretty challenging. Believe me. So, but it will help you instead of just grabbing the library, which is the kind of thing I do. An array and a struct, then you pass the struct to other functions. Does it decay? If you put an array and a struct, and then you pass the struct, yeah, I assume so. I assume it does, but I don't know. We'd have to test that. That's a great side quest as well. We talked about pointer decay before, and we're not going to go there now. Pointer decay is when you try to use a character array using the bracket notation, and you pass it to a function, and the function is forced to accept a pointer, and therefore it loses its ability to say how wide it is. So size of doesn't give you the right information. I noticed that this particular exercise, I think the reason that they're using character arrays like this is because they do depend on the size of operator. So I don't know. What I want to do is I want to do this exercise, and then I want to change it to do an array of string pointers. and see if it still works. I think it will. I think it will, but we're gonna try that later. So we got 10 minutes left on this one. Let's see if we can finish this one. So the string function will search for the second string in the first string. A pointer is like an int, not a long. Are having a good life on Ubuntu 4. Oh God. A pointer is like an int, not a long. Did I say int instead of a long? A good life on Ubuntu 4. It's definitely a long, but nobody here knows what a long is, ancient. A long is a long integer. So when I say it's a number, it is an integer. It's just a super long one, right? So he's being pedantic because long and int have different, they're short. There's all different sizes of numbers. And so, okay. A pointer is like an int on a 32-bit architectures. Yes. A pointer, let's put it this way. A pointer is a number. It's an ln, actually, if you want to print it out, or you either use p or use ln. All right, so numbers have different sizes. The str function was made to search for string. If it finds a string, it will return the address of the located string in memory. And the example here, the function would find that the fun substring begins at memory location 4,003. Because why? Because this is 4,000,123. It gives you that specific number. But what if string can't? It's actually not that number, but you know. But what if string can't find the substring? What then? In this case, hey, welcome. In this case, string returns the value 0. Can you think why that is? Well, if you remember, C treats 0 as false. And this trick right here is super important. What is 0? 0 is false. It's actually not 0. What it treats as false is null. It treats 0 as false and null is also 0. So both of them are false. This means you can use string to check for the existence of one string inside another like this. You can say, okay, here's one, here's another one. If blah, blah, blah. Why can you check it? This is the same as saying if string blah, blah, blah equals 0. So that would be a no, right? So I'm sorry, equals 1 or is greater than 0, because 0 is false, right? 0 means I didn't find it. Now, strictly speaking, the only reason this works is because string this threw me for a loop. String returns, if it finds it, it returns this big ass number. The first time I saw this is, if you've ever done any coding in any other language, you're going to get confused by this. All right. So if you've done Python coding or JavaScript or something, when they have substring, what do they return? And this actually confused me. I tried to implement it this way. So in the C version, if it's found, it returns the memory address. That means it returns a pointer, it returns a big ass number. Okay. Even if it's the first character. Now, if you've done any programming, any substring matching in any other language, particularly interpreted languages, that's going to confuse the hell out of you. Because you're like, what? And the reason those other languages, and I don't want to confuse people too badly, other languages will return basically 3 things. If it's found, it returns the position. And in other words, the position in the string of where it is. And in Go, it does this. So it'll return like a 0. 0 is a valid return number from those programs. Because why? Those languages. Because 0 means it's the first position, and that threw me off. And for that reason, 0 is a valid, successful return value from other languages. I'm saying it because if you might be confused if you code in another language. And in order to get around that, so you can do this kind of thing, they will make I didn't find it into a negative number. So they'll return like -1 saying, I couldn't find it. It wasn't in there. 0 means it found it. It was the very, very first thing. 2, 3 means it was found. It was like position 2 in the array. So those are other languages. Let me say that again. Those are other languages. C doesn't do it like that. Because C returns the memory address of the beginning of that substring, it will always be positive. It will never be 0 unless it can't find it. If it can't find it, it would be 0. So that means if it returns the first position, which would be 0 in other languages, in C, it's actually 4 million. It ends with a 0, but it's 4 million. It's well above 0, so that counts as true. And then they use 0 as false. This might throw people who've been coding in other languages, right? Most of the POSIX functions return 0 in success. Yes. So we very often use this as a bang before the function call, right? Testing for blah. Yeah, this definitely threw me off when I was trying to write my version of it. I was like, what the fuck? I returned 0. 0 should have been the first character. That's valid. It's actually not. But because it's a memory address, that's what helps. Okay, so I've said it 10 times now. Hopefully that sinks in. So let's see how we can use string in the jukebox program. All right, so I don't know. Let's catch up a little bit. So first of all, how would we? Let's jump ahead. All right, it's helping us out here. It's kind of giving us the answer, but I don't want to give you the answer. Just if you want to jump ahead, you can. We got 4 minutes left. So let's read this for the next 3 minutes, and then when we come back from our break, we're going to go ahead and really dive in. Now, when I say break, I mean some of the time to go to the restroom or something, but it's also 15 minutes to answer all kinds of questions. So if you have questions, that's going to be the time of 3 minutes. Let's read this. So let's see. The pool puzzle. The guys in the lounge had already started to write the code to search through the track list, but oh no, some of the paper they were writing to the code has fallen to the pool. Do you think you can get it and take care of it? So they're giving us. They're kind of helping us out here. They're doing a number of things that I don't like that we're going to actually change later. First of all, they're passing in a character array instead of a pointer, and we already know about pointer decay, so that concerns me a little bit, but we'll figure it out. And then what are they doing? So void just means the function doesn't return anything. We talked about that. Hey, look, you're creating a separate function. Presumably when you get around to writing the main function, it will call this. Okay, we'll do that. And then we have, this is the for loop. So we did for loops already. So this starts at 0, and then, well, it's less than 5. So this iterates how many times? 5 times. If you put 0 here and you always use less than, you can be guaranteed that it's always going to be 5 times. Because this is the outer bound. It never actually hits 5. So we'll look at this. Just the easiest. It's just easy to remember that. If you want to play around with less than or equal to, blah blah blah. The easiest way to loop is to start at 0, use less than as your operator, and then just look at the number and know that's how many iterations you're going to get. It's just visually easier to grok. But for now, we need to just know that it will run this piece of code 5 times. We did for loops already. I think we did for loops already, didn't we? Yeah, okay. This is where you check to see if the search term is contained in the track name. So and we already know what this is going to be, right? Substring or string. And then the first one is the string. So that's going to be the track item, right? We know we only have 5 tracks in this case, so this is going to be the track. And then the second one is going to be the substring that we got from the user, or the search for parameter. Search for is going to be here. And it says printf track %i, one value will need to be an integer. This is which track, so counting from 0 to 1, right? Now this is interesting because we can't do track 0, right? We can't do track 0. So what's going to get printed there? Whatever goes here. So that means that this value right here is going to be I plus 1, so that it looks good to a human. So that's going to be I plus 1. And then we're going to put the string. This is going to be the name. This is going to be the name of the string that matched. So that is what? That's going to be the name. So that's going to be, we're going to look it up and we're going to say tracks bracket I, and that will give us the full string of that track, and that should give us the thing. So I think we can answer this now and we can take our break. So search for I tracks I think that there's actually a bug in here because I think this says track 0. It's not track 0. It's actually, I think we should probably put I plus 1 in there. They want you to put I, but it's probably I plus 1. This has got a little bit of a bug. We'll put this in and we'll see. B, the compiler. All right, this is false. We spent 30 minutes on this to discover that it's false. This is totally broken. None of these answers is correct. While you're taking your break, if you want to, you can go out and find the errata for head for C and you can see the right answer. But in the meantime, I think you should look through all of these answers and decide why every single one of them is wrong. Talk about confusion. This is actually one of the worst parts of the book right here, because this would confuse the hell out of a beginner, because they'd look at it, staring at it forever, thinking one of them was right, and they would lose all that time not knowing that they're all wrong. Every one of them is wrong. Every single one of them is wrong. And see if you can find out why it's wrong. See if you can be smarter than the book. All right. And then they have the solution down here, which I don't mind showing you because we just told you. If string, tracks I, search for blah, print I think this should be I plus 1 personally, and then tracks I. So we talked about that. All right. So the other stuff we don't need. The compiler solution is totally wrong. See how they did 79 here instead? This is not the correct solution. This is not, because this has got to be 79. So you can go try that and understand that, and we'll go through that. But we're gonna write that function now, and when we come back, okay. So again, from between now and 12:15, we'll be back at 12:15. Go ahead and have a look here, and I'm gonna walk away for a bit. Back at 12:15. You just look down here, and you can see the time and my time, and we'll be back. All right, talk to you in a bit. That is from the real book, yes. The book has a really substantial error. You can go look at that. I'm just going to walk around, but I'll be back to answer questions. We're going to start again at 12:15. All right, I'm just taking a snack right now. Let me know if you have a question. Yeah, you need to get yourself a plushie when you get confused. Get yourself a plushie. Get yourself a plushie, something really soft. Get yourself a nice soft plushie, and you can touch it when you get frustrated. And it will, I'm not kidding, it will lower your stress level. You will feel the dopamine flow through your veins as the frustration leaves your body. It's impossible to be upset. In technology, you kind of have to have some way to reduce the stress. God knows you do. Do yoga and have lots of stuffed animals. And a really cozy spouse. That's, or significant other. That's a good way to get through it. And listen to Chill Up. I'm telling you, it works. Oh yeah, I've read lots of Dostoevsky. Mm-hmm. Back in the day, I had to read it in the Russian. Да. Я прочитал «Преступление и война» на русском, я думал. Давным-давно. Anime waifu body pillow? Oh, I think that's a great idea. Преступление и наказание. Да. I mixed up my names, yeah. Да. Я перепутал все это. Quiet streaming. Well, sounds like you're new, so that's in my about. Привет из Москвы. Ну что? А из North Carolina привет тоже. Pixelbert? No, dude, we're doing C all day. I was not able to fix Libert. Nope. We're not going to do Libert anymore. I'm going to answer the first question there. We have until 12:15. We got another 5 minutes. All right, so what do we do here? Read the about. In general, you're a simple man. So today, this is the plan anyway. The plan is for Saturdays to be 4 hours plus an hour break interspersed of beginner content. So boost content, we call it. And I have a calendar. If you go to RBX, if you click on boost, you can go get that. Okay. And Sundays is AMA from 11 to 2. Now, sometimes it's going to change depending on if I have a date with my wife or I'm out with my kids or something like that. But for the most part, we're going to do that 5-hour block every week so I can stay on the annual calendar. I'm really going to try hard to stay on the annual calendar. The rest of the week, I used to have it all, planned out. I was going to do yoga this day and I was going to do IRL and running and everything. No, I just got rid of the whole plan because I don't know what I'm going to be doing. Every day, though, I'm pretty much going to be doing co-working. Co-working is where I'm doing my job or stuff related to my job. And a bunch of other geeks that do the same kind of job as me are going to be in here doing infrastructure engineering, stuff on the terminal, Kubernetes, cloud native, that kind of thing. So that might be not something you're interested in. It might go way over your head. But, and if you ask questions during that time, we probably won't be able to answer you. Firmware development, yes, Vancart, we have people doing all kinds of stuff. We have people doing everything. We have security people. We don't get that many web developers. We do have some. I did web development for Nike. I was their webmaster, but it doesn't matter. So, yeah, we do Kubernetes pretty much all the time. So lately, so if you watch tonight, anytime past 4 o'clock tonight, I'm going to be doing Ansible, Kubernetes, and Terraform because I need to do it. I might spend some of that time writing the outline content material for the curriculum that's going to start on May the 4th. This down here is my deadline reminder. A lot of bash scripting too, by the way. So in 100 days, May the 4th, we will be starting our annual cycle. So I do a variation on the same content every year. And we're going to start in 108 days. And what is it? 108 days, 21 hours, 57 minutes, and 32 seconds. We will begin the beginner boost, which will teach you everything you need to know that I do. Pretty much. It'll get you started on it. So how to use Linux terminal, why Linux, why Docker, blah, blah, blah. If you want to do last year's boost, you can go to the boost thing and do 2021. But it kind of stops pretty abruptly. It does. It stops pretty abruptly because I got frustrated because we hit the networking thing and I realized that it needs to be its own boost all by itself. So I'm slowly but surely working on writing some books that hopefully will be out. Stuff changes so fast. Books are kind of hard to do. What was the other question? libvirt. Oh, proportionate. We're not going to do libvirt. This is what we're going to do. We're going to set... The biggest problem is because Terraform doesn't know what to do. Terraform has a big problem dealing with being on the same computer as KVM. I have a book about that. Yep. If you go to the boost, the books I'm going to write are listed at the top. Yeah. I put the books I'm planning on writing at the top. And I'm going to use the boost content as the basis for the book and vice versa. A lot of the boost content is stuff I've been doing for years for SkillStack. So if that stuff excites you, you want to do that stuff. No, it's not. Not with libvirt. Not with libvirt. Did you figure it out? Is you have to change your QEMU settings to turn off. There's a whole bunch of bugs on it. We actually found the bugs. I'm like, fuck this. This isn't easy enough. I can't teach it easy. The best way we're going to do it, we're going to put Terraform. Let's put it this way: the libvirt provider is broken. So there's open bugs on it, and it doesn't have a lot of support. So Terraform might work on the same computer, but if it does work on the same computer, we're going to have to make it use a different provider. libvirt. Did you libvirt by itself or did you TF on libvirt? Did you notice that provider isn't supported? It's had years. It's been. No. The problem we hit was permissions. There's some sort of permissions problem going on. Because, yeah, we can take a look at it later if you want. Oh, I know you can. That's the problem. The problem we had is that it would pull down the image and it would copy it to root in the volume directory. And then Terraform couldn't get access to it anymore. It's an open issue. There's a lot of workarounds to get around it. Yeah. There's actually a setting in the QEMU comp file you can go in and change to say, I don't want to do this or I want to run it as this. And to tell you the truth, kind of felt like we were swimming upstream. So we're going to restart here. Oh God, we're over time. Proportion, let's talk about it later if you're around. If you're not around, let me know. The bottom line though is we're gonna you have a workaround. Yeah, let me know the workaround. If you don't have a workaround, It didn't work. It did not work. Mm-mm. Yeah, I spent 6 hours working on that with some of the best minds and CTOs in the area and engineers, and all of them had the same problem. We all concluded that doing that is a bad idea. Better to put Terraform on a system and then put the system you're managing with Terraform on another system, even if it's a VM. So we're going to try to put Terraform in a VM today. Okay, back to C. Back to C. I don't want to be too much of a liar here. I do think it's important that we take breaks, though. Otherwise, we're all going to get burned out. Oh, boy. My tummy's growling. All right. So, to replace Vagrant, good. Please come on back. Please come on back and talk to us about that, because we start with Vagrant and we throw it out. We threw Vagrant out. All right, so back to C. So here we go. Let's try this. So first of all, we need to write a function. So we're going to write a function. You don't do func. We're going to make a function. We're going to do void. And we're going to say search tracks. And we're going to make it so it doesn't have to return anything, right? But it does need to accept something to search for. Now I'm going to stick with what the book has here, and then we're going to change it to be what I like better. I don't like using character arrays as arguments. I think it's bad. I think you should use a pointer instead. So if we do, yeah. So let's do character str. All right. We're going to search for that string. This is the string we're going to search for. And we could say I'm searching for a string or whatever. And then we need to loop through everything. So if we look back here, we need that part we don't need. They have find track. Should we do find track? Let's do that. Find track. I want to stay on. I'm committed to staying with the book so I don't lose y'all. I feel like I've done a little bit of that too much. So we need to do the loop, right? Well, so we're going to do for I, as I said, equals 0 first of all. Let's see. Init check change. Remember? Init check change. Initialize, check, and then change it. And you can do this without a for loop, by the way. You can use it with while loops too. But so I is less than 5. I don't have any lint or anything. I plus plus. So that means add one change. And we're going to use brackets, even though in this case, I don't know, you could probably get away without it. Now, I is going to blow up right because it hasn't been declared. So we need to say int I. I is going to be an integer. And then for each line, we're going to check. Inside here, we're going to run something. We're going to say, we want to say string, a semicolon. And we want to look for, the first one is, what are we looking in? So we're going to look in tracks I for, actually, we're going to look in tracks I for the substring that was passed in. So the str that was passed in for this string here. And that is a string pointer at that point, but that's fine. It gets converted. It decays into a pointer. And we don't need to do size ofs or anything, so we're probably good. Let's see if it works, shall we? So, and then we put something like put s. Let's see, put s. Search term. I don't want to get too fancy with this. And then what? Then we need to read it. Now we can use scanf, or there's a million ways to read. I think the best one we did was fgetS, right? I think that was our favorite, and I think that's the one they use as well. Yeah, they did. Good. That's that limits how much you can get, right? And it's safer than scanf. We talked about that another time. So fgetS takes what? Let me see if I can remember. It takes Wait, does that return a thing? Search for, all right. Yeah, that's why it's wrong. That's why it's wrong right here, because of the 80. That's not correct. This is wrong. So we need a search term to put it in. I keep forgetting we have to initialize that. So let's say a character array, a character search for, and we'll make that, we'll say it's, why is 80 wrong, by the way? 80 is not wrong. Why? But 80 is, in this case is not wrong, but why is it wrong down here? Why is it wrong down here? We don't want 80. Why don't we want 80? I think fget_s takes one off of that. There's a bug here, though. Definitely a bug here. Because it goes from 0 to 79, right? Right, this is supposed to be 79. Yeah, so that, does it take one off? It does take one off. Does fget_s take one off automatically? There's a bug in there somewhere. It's an off by one error, right? Yeah. I think this needs to be 79 because this is literally the total number to search for. And we want to read it from stud_in. That's the standard input. That's just a standard term. And then we want to find the track. Let's actually just do a call to print it. Printf. So you think it should be 80? Well, I can't remember right now, so let's go look. I know that there is a bug in there. I'm trying to remember where it is exactly. It's definitely an F. It gets n-1 because it puts 0. Does it? It's the one that does know, right? There's one that doesn't, though. I'm trying to remember. So, nope, that's not the one. No, we were doing size of, and it was wrong. Yeah. Oh, it's scanf. Yeah, we were also saying that scanf is wrong. Yeah. Okay. So that makes sense. All right. So this actually is 80. Add a null character, doesn't it? This is not correct. This was actually going to blow up. I know it does. One less than size characters. Reads in at most one less than size characters. I think that, oh, I know what, I think what was the errata? Go find the errata. Somebody find a link to the errata. There's definitely a problem there, and I can't remember it now because I'm all discombobulated. So, but there definitely is a problem. And it may or may not blow up. Putting a limit of 70 characters per track. Yeah. Actually, this is supposed to be 79. I think that's the problem. No, it needs to be 80 because of the null character. Never mind. Using scanf with 79. Yeah, this has a problem. Yeah, this is the one. Here, let me show you the errata just because we've been talking about it. There's actually a bug here, and it's an off by one error. So, and then there's two answers, and then there's a bug in one of the answers, which was really confusing. So, here it says, so here we go. I think this is the one, right? So yeah, I'm trying to find the exact right one. There. So this is wrong. This is right. It depends on new line. Yes. If it reads in at most one less than the size, yes. They don't handle the new line by added by fget_s in the example, not an up by one. Yeah, something like that. Here, this is the actual answer. I remember seeing Don here. So the line fget_s search for 80 SDN should be replaced by scanf 79 search for. Oh, that's right. It doesn't. I remember. It doesn't truncate the search item. Yeah. Oh, let me show you. Because it leaves the carriage return on there. right? So we're going to put this. I'm going to put wrong leaves on the end. And then it never matches because it's got a line return. So it doesn't match. That was the problem we ran into. Now I remember. So they just don't handle the new line. Right. It's not long. It just doesn't handle the new line. So their fix is this, to use the much more dangerous scanf, which says, which limits the size. The reason scanf is more dangerous is why? Because people forget to put the limits here, or they would put the wrong limit. They would put 80. If you put 80 there, it's wrong. Why? Because scanf actually doesn't account for the null at the end. This is why so many off by one errors exist in C, because it's like there's just so many different ways. There's like one thing actually counts for the extra one, and then the other one doesn't, and that's a pain in the butt. It is. It's like I don't want to deal with it. So if scanf, right, but annoying. So Tiny one with his foot guns, yeah. So scan, so like, because I mean, you would think, oh hey, I'll put 80 here. No, why would that blow up? It would blow up because it would read the null in. No, it wouldn't. It wouldn't read the null in. It would read a 79 character string, and this is going to chop off. Actually, scanf does chop off the line returns automatically. I'm pretty sure. And she says that here. This up here, I made the mistake of reading this. This is actually wrong. Function used to get search. However, fgetS will add a new line character to the end. It's not the fgetS that adds. Yes, it is. To the end of the string. It doesn't add a new line character. The new line character is added by the user when they press enter, because they actually press the enter. It's called a chomp in Perl. You have to like get rid of it and submit the searching. The new line character must be removed and replaced with a null character in order for it to actually match one of the strings. There's lots of ways of doing that, but this is the scanf is their way. Without replacing the new line character, the code as listed on the page does not work. However, the screenshot on the next page shows it function properly. An example fix can be used directly after the following line. So this is where they get the whole 80 and search for string length, search for -1. This is actually also wrong. Search for this. Note from the author editor in the code on pages each time function is called to add the following line of code after it. So this is another thing. Search for string length -1. String length search for -1, it goes to 0. So that actually just puts a null character, but we found out that has a bug. We actually did it. This also has a bug, and this turns out to be the right way to do it. So that's annoying, but that's just how it is. All right, so we've got our search for it. Now we can actually do it. We can say find track. We can do our printf, right? So let's say, well, what is it going to give us? It's going to give us the substring. Actually, we're not returning anything. We just need to do the printf. We can do the printf right here, right? So let's do that. Let's do the printf. Okay, so now we need to do their condition. So we just say if we find it, right? If we find it, then what? Then we need to print it. Printf. Make sure I got this. Printf found track, and we're gonna do I, and so we'll do \n, and we can put the name of the track as S. So we'll put I for this, but I actually think I plus 1 is a little better. Because why? Because that's like, not 0. And then we'll put the name of the track. So that would be tracks I. That will give you the whole thing. All right, so that should find our track. And then we can just do this. We can say find track This is a lot of code to write without checking it all out. I usually will check it before I get this far along into it. Let's do that. Find track, search for, and let's see if that compiles. So make /tracks, and looks like it did. Search term. Oh, it put it on a different line. We can maybe fix that later. Let's say, what did we put in our tracks? Letter A. Yes. Okay. So A found track 1. What have I done? All of these have. Let's do a different one. Let's fix our code though. So that was pretty fast. It ran really fast. It executed fast. Let's do this. Let's say, let's do a printf here, so that it's on the same line, right? So here we go. Search term. Let's search for what, and it says, hey, here's all the stuff that have what in them, right? And also it's case sensitive, so if we do lowercase, it doesn't find it. What, you see that it finds it, right? And that's pretty damn fast though. I really want you to just take a moment to realize how fast it does the search. I mean, we're writing in the fastest possible language short of assembly, so it's gonna be fast. And you know, people shouldn't see all the time, but it's like, it is definitely fast. I mean, nobody will ever say C is not fast. That is not a critique of C. So there you go. In fact, it's the fastest short of assembly. So let's go back to our thing. We actually did everything that we needed to. We got our errata that worked, and we're done. We're done with that particular level. We have several minutes left. We have another half an hour for the next level, so let's keep going. And I think we can say goodbye to that one. Let's go ahead and save this. So I'm going to add. I'm going to do git add dash. No. I mean, I guess I could do -a tracks. I want to add everything in tracks. Commit that and say add tracks from chapter 2.5. And I'm going to go refresh rate, bottleneck, see compile code. Yes. Git push. We'll go ahead and push that. We learned about getting the boost in other places. So, and you know, all the stuff we're doing with BI and everything. All right. So let's go back to the book. I think we successfully knocked that one out. And so it's time for a code review. So we already did this. We talked through it. Even faster than ASM would be a chip designed to specifically do this program. That's true. That'd be the only way. And that's how GPUs work. That's how graphics drivers work, right? They used to all be software. Can you imagine like playing TF2 with software? Even it would be slow as hell. All right, so here we have that. Like we said, here's the search. We did. You get your Arduino. Here we have all of this good stuff. Arduinos are fun to write different C things code for as well. It's important you assemble the code in orders. The headers are included. You can't put the function down below for some reason, even though it's compiled. Just know that. So this is their test drive. We already did the test drive, so we can skip all this. Let's read the dumb questions. Why is elliptic tracks defined as track 80? Why not 580? So let's go ahead and read these. Hey, Master Lich. You could have defined it that way, but the compiler can tell that there are 5 items in the list, so you can skip 5 and just put blah. So it automatically fills it in with whatever the length is. But in that case, why couldn't we just say blah blah? Because we can't infer the size of memory necessary for the thing. The track names are different lengths, so you need to tell the compiler to allocate enough space for even the largest. So you have to say how big it's going to be, right? Now, there is something we're going to try after we get through this chapter, and I want to see if it's going to break stuff. Does this mean that each of the tracks has 80 characters? And no, the program will allocate 80 characters for each string, even though each of them is much smaller. So the tracks can take 80 times 5 characters worth of space memory. Yes. Now, consider, though, that includes the null void, right, at the end, the null terminator. This is called head first C. The book we're following along. What happens if you forget to include a header like in the string.h? For some header files, the compiler will give you a warning if it doesn't include them. Otherwise, it'll just do it. Why do we put the tracks array outside of the functions? Because we wanted global scope. And that the main reason for that is because we're cheating. We definitely are cheating here. Because why? Because we didn't want to have, and I kind of want to go over this later. If we hadn't made it as a global array, if we passed it in, so let's say you want to make a function that was truly functional. In other words, you passed in the list of tracks, a pointer to the list of tracks, and you pointed in that would be a more functional program that was, didn't have stuff all over the place. This kind of cheats because everything uses it. And it's largely going to be a constant. The truth is, in real practice, you have to return a track right. In real practice, this would never happen. You would have something else that had a pointer that was malloc to give them set of memory and all of that. You'd read it from a file or whatever. And then that would be passed in. That would be passed in. So they are cheating by making this, by making doing it. They're just kind of cheating. I do not. Now that we're talking about C right now, though, but if you can talk about that later if you want. Now we've created two functions. How does a computer know which one to run first? The computer will always run main first. That's just a given. Why do I have to put find track function before main? C needs to know what parameters in a function takes and what it returns, what's the return type before it's called. That is a little silly. It doesn't need to be that way in Go. What would happen if I put the functions in a different order? In that case, you just get a few warnings. I didn't know that. So I'm pretty sure the way I have warnings turned on right now, that would be an error and it wouldn't let you do it. I think it would let it compile, but it's a bad form. You're supposed to... function hoisting is when the function gets pulled up into where they need to be. That JavaScript doesn't. No, this doesn't do it. Why did we put the tracks array definition outside? Okay, so we got all that. So here's the bullet points. You can create an array of arrays using character strings, and then the two different types. The first set of brackets is used to access the outer array, kind of like a matrix, if you know what that is. The second set of brackets is used to access the details of each of the inner arrays. A string header, string.h header, that gives you access to the set of string manipulation functions in C library. You can create several functions in C program, but the computer will always run main. We've been using functions a lot before this, so I feel bad that we jumped into that right away. Here's the final version. We already did this. The guys are working on a new piece of code for the game. String printf. This worked out. I don't get this one. And they created a function that will display a string backward to the... Oh, right. This is a different exercise. So I'm going to do this one next. All right. So we have 15 minutes. We can probably get into this next exercise. This is a different exercise. This is going to reverse a string. And that'll be a fun one. Let's do that. First, though, I want to make this a little more like I would like to write it. I'm going to try some things and I might break it. It's okay though, because I saved it, right? So it's all saved to GitHub. If I want to revert back, I can just check it out and get my old code. So I'm going to experiment. The first experiment I want to do is I want to change this into your university. I want to change this into this. Now, what did I just do? Now I've said, now I don't have arrays anymore. Now I have character pointer array references. Yeah, we're gonna YOLO this. I also don't want it. So let's just start with one change at a time. I was reminded yesterday, one change at a time. Make one change, test it. Make one change and test it. Are these the same? Are they the same? Well, we're gonna find out. Now, we're gonna find out. Let's try it. So let's try our make. So, can't do it. Must have bounds for all dimensions except for the first. Declaration of tracks as a multidimensional array must have bounds for all dimensions except the first. So the answer to that would be, I get a warning. It's still, must have bounds for all dimensions except the first dimension. So So the first would be, now we can put 80 here, right? Is that going to be different? Let's try. Nope, doesn't like that either. So it's like, nope, can't do it. Oh, wait. Over here, it can do it. I can't look up this specific item, right? Because we're trying to put pointers in there. Now, I actually pulled this one off, but I believe it was probably too hard to do it. This is how I did it. I just made an array of pointers. All right, so let's go back and try that. I actually think that this is easier. So we actually don't need this here anymore. Why? This is, so what even is this, right? This is a single array of pointers. And the pointers are 2 character arrays. So it's not an array of arrays, so to speak. It's an array of pointers. And those pointers actually happen to point to the character arrays. Now, I'm pretty sure this is what I would want to do if I did this. And it still works. It does everything you want, and it's easier. Yeah. So values to character arrays. Yeah, we don't want to be able to, if you do it this way, you can't assign characters to it. And this would be like a constant. You probably want to make it constant. All right. So this totally works. Now, but make sure you understand how this is different. This is now an array of pointers. And what is a pointer? A pointer is a memory address that points to the first letter in the constant space of the of the memory, constant area of memory. Instead, the other way, the way we were doing it like this, it's not. This is still in this. It's the pointers in the stack. No, I don't believe it is. Somebody can correct me if I'm wrong, but when you do this, so from what I understand from last time, the big long session we did last time, this creates a modifiable copy of all of these string literals in the stack that could be modified if you wanted to. Right? This, which uses more memory, this uses more memory than this. Here, it's not on the stack. It's a data segment because it's initialized, right? But this one creates a bunch of string literal constants in the constant section of memory that are pointed to directly. So there's not a copy. It can't be changed. These values can't be changed. They're constants. We're not declaring them as constants. Probably should, but this can't be changed. So this, from what I understand from last week, and I'm still a C noob, this uses half as much memory because it does not create the ability to change it. It's like, this is always going to be this. And it's so, yeah. So these take up half as much memory because they don't need to make the copy on the stack like the other notation does. So that's the first change. And by the way, string doesn't care because it's a pointer. At the end of the day, it's going to use a pointer. It takes the track and when you pass in the track, it decays it into a pointer anyway. So it's already a pointer. So you might as well just start with a pointer. So I actually I know this is confusing for beginners to understand, but I actually think this is much better code because it's a constant, it's whatever. So, and that way it gives you the same thing. All right. So, now the second part of this is, and going back to the section on pointer decay, which was something I learned about in this session. I did not know about pointer decay until I started studying Head for C. This has pointer decay. I absolutely hate passing this format of anything into a function. I hate it because it's misleading. It's exactly the same thing. It's just misleading. It makes it look like it's passing in an array or something. It's actually not. It's just putting in a pointer. We covered pointer decay in a previous chapter. A pointer decay. So let's make sure this works first. All right, so that works too, right? So So in this case, this and this are exactly the same, functionally the same. They do the same thing. This is, hey, I'm going to pass in a pointer to a character array, and this is, hey, I'm going to pass in a pointer, period. And the pointer is to a character, to a single character. They're the same thing. So this is much, much more common. In fact, I very rarely see this in C code. It's usually this. So it's like, hey, it's a pointer to a string, right? And then this is also a pointer to a string. So this is why you're going to see this. And this is the final version of this code for me. I don't like the version they have, to tell you the truth. I don't. I think that's much more accurate and easier to read, but good practice, right? So go back and make sure you understand pointer decay. It's covered really well in the book. I'm not going to cover that. And we do have another 15 minutes or so, actually 12 minutes. So let's go back to see what's next in the book, shall we? So I'm going to actually add a little thing here. Let's see what the status is. So let's say git add-h tracks commit change to pointers in tracks git push. All right, so pointer to a character should be precise. This is the character part of the string. Yeah, we don't know, but it's the first one, right? And since that's all we really care about, all those functions only care about whether it's pointing to someplace in the string, right? So, to some element in the string. Okay. So let's do this one. How does the compiler know where the next address is in the array of pointers when you iterate through a pointer string? How does the compiler know where the next address is? It just adds 1 to the pointer, to the memory address. Yeah, if you look at the underlying source code, that's what I was trying to do yesterday or last time. Because pointers are numbers. Yeah, because pointers are numbers, C adds 1 into the number. Yeah, it does pointer arithmetic, it's called. That's how it knows when it got to the end too. Because when it gets to the end, it says, hey, is the pointer a 0 / null, right? And a / null. And if it is, then it knows it's done. And that's the actual implementation, which is pretty hairy. It's pretty hairy. We're going to get into this a little bit here. This exercise now actually starts to look to iterate over. See, look, this exercise now actually starts to iterate over the characters in the thing. So we're not going to be writing our own string. Yeah, pointer arithmetic. Yes, we were talking about that. Yeah, S1 equals S plus 1, etc. Yeah, and we did a lot of pointer arithmetic earlier. But let's do this. So we have 10 minutes. Let's see if we can get this code written in. The guys at work are trying to make they're trying to make, so what print reverse will reverse a character array, right? A string. So what this says is, it says, okay, give me a pointer to a string. All right. So they actually use the pointer notation I just talked about just now. So they kind of led into this conversation. Messing with pointers every day. Really? Is it in real life? Is that true? That'd be interesting to know how you do. So size t is just an integer used for storing the size of things. So size length, string length, strlen. Now this is interesting. The string length, actually, we looked at the implementation. Somebody reminded us of this. The string length implementation actually iterates over every character in the string until it gets to a null in order to count it. It does it so fast, it's fine. But if you're going to be already iterating over all the characters in a string, then that's a waste of time. You don't need to do that. This works out the length of the string to string length ABC equals 3. But it does it by counting. It literally pointer arithmetic to every character until it gets to a null, and it keeps track of that number and counts it and returns it to you. That's how it counts. It's the only way to count it, actually, because that information isn't stored anywhere, so you have to do it. It does it so fast that you can call it, no problem, but it's not stored as a part of it like size of is. Size of apparently, even it's super dangerous to use size of because it's, dependent on the system and it's subject to pointer decay and stuff like that. It is saved by the compiler into somehow, I don't know how, it's saved as a part of the information associated with the character array. So that number is available to you at all times. But string lang actually iterates every time you call it. Every time you call string lang, it iterates over the entire, all the characters in the string character array. Size of is not a macro. So so let's try this one. We have 7 minutes. Let's see if we can pipe time. All right. So size of is an operator. Yeah. And it's different than string length, so it's easier to get them confused. So let's do make directory reverse. Again, we're doing a new project here. I'm going to reverse. We're going to make file. We want all to be reverse. Is about the size of types. Yes, it is. And it just so happens that the size of character arrays is right. So that's a good point. That's a good point. Size of is about the size of anything, not just the size of a string array, but it's come to be used for that in the case of a character array, otherwise known as a string, until it hits pointer decay, which is going to ruin your day. Compile time and string length for runtime computation. I think that's probably fair. I think that's fair, unless you're already going to iterate over the thing, right? I mean, from a practical perspective, just use the strings library and call it a day. You don't really care. I mean, it's so freaking fast that even the iteration over the string to count it is not going to take that much time. So let's do this. Let's do reverse.c, include stdio.h, int main, and we're going to return 0, and that's all. All right, so we want to write a function that does a reverse, to print reverse. Let's do that. So let's make a function. So this isn't returning anything. So void print reverse. I'm going to give it a character array. I guess CR better. So there's nothing to return here. And then we're going to call it. So down here we'll call it print reverse. And we'll ask them for something. So it actually doesn't matter how long it is. So let's say character string. Let's say character reverse me. We'll say 80. We'll say 80. And we'll go grab that. Now we can chomp it if we want, but we don't care. We'll use scanf on this again. So scanf, but in this case we have to do 80 to 79. We want 79 characters. Is it C? Yeah, 79C. Is it C or F? I can't remember. That's why I'm doing this, so I can put it in my memory. Semicolon before I forget. Reverse me. Print reverse. Reverse me. Reverse me. All right. And all right, so let's just see if this will compile. Okay, so let's say I type a chat there. Oh my god. Really good. malloc is really good for use of size of. Yes, when we get to malloc, we haven't done malloc yet, but yeah, I don't know if we're going to get to it in this session. I mean, in like overall. So printf, we're going to say printf -n, and we're going to say s. Is that a thing? I think it is. So we'll say would reverse blah. Let's see if I can just get this to compile. Make nice reverse something. That's interesting. Why didn't it? Oh, because it was 79 characters. I feel silly. Tracks Let's see. I need to get my scanf back. Search for it. Oh, it's S. Derp. Derp. What are we working on? We are working on C coding. We're about to take a break here. We can shoot the breeze for 10-15 minutes. Make dot reverse something. Would reverse something. Okay, so now let's actually write the reverse code in the next 2 minutes. And we can write the reverse code. Actually, we can leave that off. Let's go through. We need to iterate over the characters in the string, right? So how can we do that? We need to iterate over. So we need 4. We're going to need an int here. A book, or you do the book for the audience. I do both. It's called co-learning. And for me, it's a good reminder. Plus, I need to. It's a good guide. Yeah. So I'm gonna break. I stream all day pretty much. for I equals 0, I is less than what? I is less than what? I is less than what? String len str. Right? I plus plus. And so we can do that, right? Now let's actually just iterate over the first part of it. So let's just do printf %c, which is character. And this should just print it all out, right? So let's do str I and see what happens. Let's see what happens to that code, shall we? Yeah, me too. And we're going to make that. Oh boy, I did that wrong. Why does it blow up? Because we didn't include it. Include. So I don't know what you're talking about. String.h. It's angry at me. Yes. Oh, still angry. Comparison of integer expression of different signedness. Size t. Oh, we have to use size t instead of int. Can I use it? I wonder if I have to cast it. I don't know. I'm going to cheat on this one. Size t length equals string length s. Oh, this has to use a while loop. That's interesting. This is interesting. Okay, I wouldn't have guessed this. I would not have guessed this. So this is, we can't use this for loop. We have to use a while loop. Unless we're going to cast the number. Can't we cast the number? Can't we cast the number? Well, I'm trying to do it my way. Size t. Yeah, I would think we should be able to cast the number, right? Don't cheat. I want to. So, okay, so we'll say the len equals string len str. We'll do it the way it does it. I still want to try this though, just while I still have this here. Otherwise, I got to rip all this code out. Cheat. So we're gonna make this. It doesn't want it because the types don't the same. I is undercut. Oh, so you can see I equals 0. No, we could do int I. I know how to make this work using a different way, but yeah, see, it's like, oh no, the sizes don't match up. This is actually a good error, people. You want type errors in strictly typed languages, but if we want to cheat, we can make it a size t. I think this is cheating, but I think it will work. Yeah, it does. Yeah, it worked. I cheated. I'm sorry, I cheated. I like the 4 better. Uh, wait, what is the string length, by the way? Printf, length of string is an N. Is it an N or an I? I think it's an Li. I don't know. We're gonna find out really fast. So, yeah, I turned them into errors. So length of string I is an Li. I thought it might be. It's a long int, which just means it's a bigger number. All right, so reverse something. The length of the string is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that the length of the string is 9. That doesn't count the null at the end. So string length means, what you expect. It's like it's an actual number. So this will iterate 9 times. That's making sure not to give us the stuff at the end. That's why it works. Let's use string endlang as to try to avoid buffer overruns. Yes. Yeah, string endlang is. I'm glad you mentioned that because string lang will just keep going forever. Watch what happens if I pass in something that doesn't have a null on it. Yeah, let's blow this up. God, we're into our break time, but let's do that. Let's do that. Let's print reverse. Let's do a character array on purpose. So let's say Bork equals, and we're going to do a character array. This is a way to cheat. So let's see, B O R K with no null. With no null now. There's no null on the end of that. Right? If I want to have that operate as a string, I have to do this. If I wanted it to be the character array version of a string, that's the proper way. Right? But if I don't, if I get this off of there, it should blow up because there's no null. Right? So if I put reverse me here, if I put Bork, the string length should go right off the end and give me a null pointer error. I'm doing too many things at once, but let's do Bork. All right, so let's try that. Let's get that to run. Make. All right, so yeah, see here? See, it tells you a warning here. It's like, excess elements in scalar initializer. Oh, wait, I did that wrong. I totally did that wrong. I have to do it like this. Duh. Yeah, string endlang is much safer. C11 programmers use C99 didn't need it. Seg fault incoming. Yes. There. So here comes a seg fault. Something. There it is. How do we get the seg fault? Because there was no null on the end of the string len. But we can fix it. We can fix it by using the modern variation that our friends have told us about of string lang that you wouldn't have learned from the book. But if you do that, you can use this instead. You can use string endlang _s as a safe one. And that should actually fix it. Unless it's not included. I was like, I don't know where you are. What's the declaration of function did you mean? String endlang. Oh, they have a string endlang now. It's not even .s anymore. It used to be _s. Oh wait, we need to get it a number. We need to give it a number. We can say 80. Right? Actually that's not much better. It is better. There's no borking with scan auto add. It auto adds. Does it really? I didn't realize it auto added a null. Interesting. I did not know that. We have to pass it a number array anyway. Okay. Well, there's lots of variations on this. Let's try this one. Make. This is really fun. We're kind of on break now, just in case you're wondering. The breaking is where I screw around and not do stuff in the book. If you need to take a break, this is the time to go. So, reverse. Another kaboomy. Actually, that's still going to boom because it goes off the end. Yep. No, that didn't fix it. I'm going to do that. The internet as we know it would be broken. And you're trying to use, and they'll tell you about it. Yeah, I remember about that. Yeah. So let's do, if we, actually, what you're saying is you could do a scanf instead. So anyway, this has been fun. So again, print reverse is, we're going to put it here. I'm trusting str to be an actual string. So this is, I mean, I think it's important that you write this kind of stuff. Size, pointers in the constant character. Yes, I forgot to put the number. Yep. Since the 11, it's been doing string length. Nice. Nice. We can go use that instead. In this case, though, I'm going to actually trust it. So, but that's dangerous, right? Because somebody doesn't know and they pass it in and they think it's going to do its own bounds checking or something. It's not. So, but that kind of checks should usually be done when it's parsed into the thing. So scanf would be the place to do it. And scanf is a safe point. You can print the pointer returned by scanf. Sure. Printf. A pointer to reverse me. That, yep. And reverse me. Print string and reverse by doing pointer arithmetic. Absolutely. That's what we're going to do. We're doing it wrong right now. We have to finish it. I haven't got to that point yet because I'm screwing around with other stuff. We'll get there. All right. So right now we're iterating over the front way. Where we're going to just iterate, we're going to change our direction. Pointer to reserve. There we go. Length of string 8. And there's a pointer memory, pointer arithmetic. Yep. So let's do this. Let's say, yeah, we say length of string dash n. So we can actually do a reverse here. We can say I equals length, and we say I is greater than 0, and then we can say I minus minus. And then we print out the number that way. Do I recommend exercises you do for recommended site in Python? I don't. You don't think it'll work? Why won't it work? It's going to blow up. Why is it going to blow up? Well, let's try it. Something. It looks like it worked except for the S. Uh-oh. We got an off by 1 error. We have an off by 1 error. We have an off by 1 error, don't we? So it needs to be length plus 1. Plus 1. How's it going? So let's try that. Trial by error. Trial by fire. I equals length minus 1. No, it doesn't. No. There we go. Oh, wait. We got a piece of memory there. What are we missing? I equals length. Oh, right. No. Minus 1. So, yeah, because we don't want the null. The length doesn't include the null in it, though. Hey, Switzerland. Python, that's a different question. We're not doing Python right now. So, try an error programming. Yeah, what's wrong with that? That's how nature works. I would much prefer to do that and stay akin with how nature works. S0 is it's also called test-driven development. Plus S0 is the first character and SLN is the last. No, it's not, because the string length says 9 characters. That doesn't count the null byte. It doesn't count the null byte. It's greater than or equal to 0, right? Yeah, let's try that one. Nope. Comparison of unsigned is always true. Let's see. It's an unsigned. It's a size, so we can't do it because sizes are always untyped. Yep. We need to do this differently. Okay, let me think about this. We'll think about this. Because I'm going to go slowly, but... So the length of the string is the length of the size of the string character array minus 1, because... minus 1. Minus 1 because why? Because... can never, because I can never be less than 0. Yes. I can never be less than 0. I is greater than 0. I minus the length and minus 1 equals the length. Let me think about this. So here, this was not working. We know this is not working, but I want to see it fail again. I want to see this fail. So if we do this, we say something, and it does it all right except for the S, because the length of the string is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string array is more than that. So it's the null byte that's mixing us up. That's messing us up. The null byte is messing us up. So when we go, the string pointer that comes in, when we point to the first item in the pointer, the first item of the array, so the last item of the array is the length. So if it's 9, here, let's go back. It'd be, what would it be? The last item, what's the index array? Another off by 1 error for me. So if it's 9, the last item right here, that is index 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is index 8. And the length of the whole string is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the index is 0. So the address of the G is not 9, it's 8. So that is the length minus 1, right? So that's where that comes from. So we do, so we want the first character to be the length minus 1. That would be 8. So that means the first character printed would be the string 8, which would be the G. All right, so then we have a problem here. So then it goes to the next one. Let's try that. Let's see, make. It goes to the next one. So let's do this again. So it's still missing it, even though we're getting there. And so it's still getting the S. So the first one it prints is the G, and then this is length that's still less than 0. So what is that? That is, so this is I equals length minus 1, so that would have been 8, and then 7, 6, 5, 4, 3, 2, 1. So it prints the 1, and it doesn't print the 0, right? But it actually does need to print the 0, because the 0 is the first item. So we need a 0, but our condition is going to fail because we won't be able to check negative things because of something I didn't count on. And then you cannot do negative values. So as soon as I say is greater than or equal to 0, it's going to try to go and make it into a negative number, but size t, the trick we did to get it to match, can't be a negative number, and unless we force it to be something else. Yeah, so size t came back to bite us for sure. Well, I is the length of 9. So I would be 9 minus, we don't We don't want that. We don't want to remove the minus. Why would you have I equals? I don't agree with that. Because the first thing is that would make the first thing printing would be this string, and it would go out of bounds. It would be a null byte. We don't want that. Yeah. In the last iteration, we'll wrap around. Yeah. Oh, right. It'll wrap around because the index will go off the end. It'll take one away from it, and then it'll be pointing to something else that's doing it. Right. This will be fun. 2.5 programmer. Frank, you're such a dick. You really are, Mr. 10x programmer who's never done any programming for us to review publicly. Yeah, he's a dick. He always has been a dick. He knows he's a dick. He tells us that all the time. The reason I'm talking through this stuff, by the way, have you ever tried to do complicated code while doing a live stream? Because if you haven't, shut the fuck up. Okay? The reason I'm rubber ducking this shit and I'm thinking through it like this so slowly so that people can go through the same process. If you don't like it, get the fuck out. All right, I'm done with that. Okay, so yeah, when's the last time you wrote complicated C pointer one-off by errors in the middle of a crowd streaming stuff? I'm done. All right, so here we go. We have yes, 0 minus 1 is going to be a positive number, and then that's going to wrap around, which is going to be very unexpected, but it's probably good that you understand why that is, right? Probably want to know why that's true, because it's going to say, hey, I'm going to wrap around. It won't let us do it anyway because size t has to be a positive number. So the best way to do this would be to do it as, so here it tells us the warning. A comparison of an unsigned integer is always true. So that could never be negative, and that's why it would always be a positive thing, and that's why the errors won't let us do it. Thank God. Which means we're going to have to use a while loop here, which is what they did. So let's try a while loop instead. Let's change this back to an int, and we don't need it to be an unsigned int. We could make it an unsigned int, but let's see if there's another way. I'm going to get a cheat from the book. So this says the size length. Now this is just doing while loops, which I think is really dangerous, actually. It says is greater than or equal to probably 0. So yeah, let's try. Let's see here. Yeah, I think it's going to do the null thing. I think this is going to do the null thing, right? This was so the ABC length is 3. I is unsigned, so I is greater than or equals 0 is always true because 0 minus 1 would be blah. Yeah, because the reason for that is because it's an unsigned type. Specifically because it's an unsigned type, and I don't want to go down that rabbit hole. It's going to confuse beginners. But that's actually the practical C at the beginning. It says when 2 plus 2 equals 9,500. It's because of unsigned typing and stuff like that. And do string length minus 1, right? So character type array. So we had this is pointing to. I see what this is doing. So this is saying character t equals -1. This is doing pointer arithmetic. So this would be s. It would be, what would it be? It would be the string thing equals the length plus the length. It would be, yeah, they're doing pointer arithmetic. They're doing pointer arithmetic. T equals, I'm going to have to add T here. They're doing pointer arithmetic. They're trying to iterate over the thing backwards. So they're trying to do it as a while loop. Let's try to see if we can change it into a while loop. So while what? While greater than or equal to the string length. Now you could probably get sneaky with this. I would prefer to use the length of the string and just have a counter. I think that's more intuitive, but they're being sneaky. They're being sneaky, and they're using pointer array stuff. That's what they're doing. See how they're pointing to the character? So I would rather put a pointer in here. I know how they're doing it, but I kind of want to do it a different way. So if they do, so we have the size of the string. Really, all we need to do is I'm gonna do it my way, and then we'll come back to see it their way. And okay, so all they want to do is go from the back of the string to the forward, right? And those things have indexes, and we can't. So we need a counter, right? And I could just say I minus minus, and I could say while. You guys can tell me if this is wrong. It's fine. So we could say I want to count backwards. I want to say while the string. Let's see, printf length of string is li integer I, and then we're going to count backwards on it. So the first I needs to be the string length, which is a positive number, so we'd have to cast it. So the problem I have is I can't compare the numbers because they're different types. That's what's going to kill us again. We're not going to be able to compare the numbers because they're different types. I is unsigned, right? So we need to have, but you also can't compare them without casting them. Yeah, I was going to do the cast. But if you do the cast, then I feel like we're cheating. I feel like we're cheating by doing the cast. I is not unsigned. It's not. It's an int. Right. It's a regular old good old int. But watch. I can't do this. I can't do I equals len. That's not gonna work. So while I is greater than or equal to 0, that would be the index, equals length minus 1. So I want people to see that you can't do this. That's why I'm pausing, because I'm already fixing the problem. So you can't do this. This isn't going to happen because the types are different. You can't do it because of types. So watch. So if I know, but they don't know about casting yet. We haven't even talked about it. So I feel like I'm cheating because we haven't talked about casting at all. So reverse something. That actually did it. That does it. Sort of. Wait, why didn't that blow up? I should have blown up. How come that didn't blow up? That took the cast just fine. How come that took the cast just fine? That's really interesting. Yeah, me too. Master Lich, I'm glad you thought so. See, it did an internal cast? Well, that's very confusing. Yeah, that's confusing the hell out of me. Yeah. Yeah, there's something going on right there. That should have been a cast. Did you make a comment? You can, because len is unsigned and smaller size than an int. Oh, and so because it was a smaller size, it assumed it, but within the for loop it didn't. Len equals is 2 greater than 32. Yes. Okay, that makes sense. Yeah. It casts automatically when it's smaller. Yes, that's interesting. Okay, so I'm going to put a note here. Works without a cast since smaller than... There's another foot gun. People will have no... Beginners are going to be so confused by that. They're going to be so confused by that. They're going to be like, how did you do that? But that works. That code works. That code is actually really kick-ass simple too. Wait, yeah, because since smaller than size t. Yeah. So yeah. You just remember that? I think CCAS, yeah. Only with 64 bit commanders. I'll tell you, you could make I a size T. We tried that. Oh, I could. Why didn't I do that before? I feel much less dirty doing that. I feel much less dirty doing that. I do. Oh, look at that. Nope. You know why? Because it's the zero comparison. Ooh, it's not going to do it because signed T is an unsigned int. That is so cool. That is cool. All the beginners are like, what the fuck? But yeah, because len is smaller than I. Is smaller than size int because T is smaller than int. Yeah, great. You think this isn't off by 1? I don't know. It works. Says no one ever. All right, so we got it. We got it done. It's definitely good. Where are the labs being pushed again? These are to my here. Head first C projects in this case. Yeah. But that's pretty standard behavior in languages. Yeah. I don't know if that's the reason. I guess that's the reason. But yeah. Simply I less than any length print FC should be okay. It doesn't work. That way that we tried doesn't work because I is unsigned and so it gives us a warning. So yeah, there's multiple ways probably. If you have a different way, please let us know. Share your version and you guys can all try it and play around with this. I mean, the whole point of this is to play with it. So that's what we're doing. It's definitely being the catalyst for that. And I'm going to add that and call it a day. We're about ready to our next break. Kind of worked right through our last one. But the work I did through the break was experimentation and stuff that, but I'll definitely take a break on the next one. So let's go ahead and save that. Git add -a reverse commit add reverse from chapter 2.5. Git push. So there's ours. You can go try that. And break it, etc. All right, let's go back to the book. Let's see what they would have done. By printing size of T and size of int. Yes, that's a good idea. No, I goes more positive in that case. Standard def, you can print size max and int max. That's also great. Thank you for that. All this stuff is great. Did you guys test it? For I equals 0, I is less than length. I plus plus. Oh, it's because you did less than len. Did it after it had already been converted because it was smaller? What did you declare I as, Brabez? What did you declare I as? Did you declare I as an int? Or did you declare it as the size underscore T? All right, yeah, size T lang for I equals less than, for int I. Can you do inline? Can you do that? Can you do inline in C? I didn't think you could do that. I didn't think you could do that. You can. Interesting. Did not know that. That's good to know. You can do inline declaration. I did not know inline declaration. They haven't talked about it at all. That's a Go thing, and so I'm always afraid that to assume something about Go and C. Because, I mean, every other language pretty much lets you declare the localized variable inside there. It's used often, yeah. Oh, God. My son's probably going to test. Okay, we'll have a break and talk about stuff like that. Let's get down to the code magnets. So what do you guys think goes here? So character T equals God damn. Why did they have a dash here? Oh, minus. That's definitely here. I'm just going to go look at it. I don't want to waste time. So they have it as char t equals s plus len minus 1. So the len minus 1. This is effectively the same thing as the y'all's for loop and everything. So yeah, s is string length s plus. So they're actually using pointers. And they're saying, so if the t is greater than or equal to s. Oh, I see what they're doing. This is crazy. They're using pointer arithmetic and the fact that memory addresses are always higher than the previous numbers. So you remember this thing we were looking at? It's not pointer arithmetic, but it's like they're using the fact that no matter what, the addresses of the characters up here will be greater than the characters down here. Good for learning to see how ugly C can look. Yes. So they're actually using the fact that pointer numbers are higher. After C99. Yeah. Was it after C99? That's good. Thank you for the information. You guys are providing a wealth of extra information, and thank you for that. Even when you're calling me a horrible programmer, which I am, by the way. So, I told you I'm a practical programmer. I'm not a good programmer. That's why I try things out until they work, and I do lots and lots of test cases because that's how nature does shit. C is hacky. Don't worry. Yes. So this is a clever way to do this. It's not intuitive by any means, and I would never write this code in production personally. I hate clever code unless I'm writing Perl. And then I love it. I love contextual clever code. Clever code gets you fucked. Don't do it. C is really crazy. We're all horrible C programmers. You want to operate on strings, which is quite a basic part, and you have to be aware of pointers. Yes. Being super fun, appreciate it. It's good. Array of arrays versus array of pointers. All right, so we have a break coming in 25 minutes. Just know that. You've seen how to use an array of arrays to store a sequence of things, but another option is to use an array of pointers. Hey, I talked all about that. We did that. I already jumped ahead. I feel good. I cover the material without covering the material. An array of pointers is actually what it sounds like. A list of memory addresses stored in an array. It's very useful if you want to quickly create a list of strings. This is exactly what we did. That's exactly what we changed ours to, so I'm not going to rehash that. It also uses less memory because it doesn't make a copy on the stack. It just points to the stuff in the constant space of memory. So you can access the array of pointers by accessing and blah. Oh boy. Now that you guys have print reverse function working, they've used it to create a crossword. The answers are displayed by the output lines in the code. Holy cow. Oh my God. This is crazy. C solution. Oh, no, I'm not doing that. I guess if you want to do that, you can do it. I don't care to do this exercise. I see what they did though. So 1 put juices C 6. So that would be 6. That would be 0, 1, 2, 3, 4, 5, 6. That would be mulberry. So 1 is mulberry, right? Yeah. 2 print reverse juices 7. 1, 0, 1, 2, 3, 4, 5, 6, 7 in reverse with a Y. So where's 2? So Y would be strawberry, starting with the Y right there. Okay, yeah. Put S juices 8. Update the code from the book. There's an errata. I posted it earlier. Yeah, if you just search for head for C, errata, E-R-R-A-T-A, you'll find it. Put juices 8. For 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. Blueberry. And the regular size frame. So that'd be 3. It would be, that's blueberry. 4. 4. Print reverse juices. Oh my God, this is crazy. Okay, print reverse juices 18 plus 7 divided by 5. Fuck. 18 plus 7 is 20, whatever is 5. Divided by 5. 25 divided by 5 is 5. So that's 5. So print reverse juice is 5. 0, 1, 2, 3, 4, 5. Kiwi fruit in backwards. So that would be T first. That would be line 4. Kiwi fruit backwards. Yep, there it is. All right. Put S juices 2. Ooh. Put S juices 2. Juices 2. So 0, 1, 2. Sharon fruit. Number 5 down. Sharon fruit. Okay. Whoa, we missed that one. 5 down. Wait, what? It's pretty hilarious, yeah. Put S. It's a pretty funny book. Juices. They do that to make you remember it. That's the same reason people do memes, to help you remember things. Like I in SkillStack, we did memes for years. Put S. Juices 2. 0, 1, 2. Sharon fruit. With a question mark on line 5. Sharon fruit. Why isn't that not Sharon fruit? I don't understand. I think this has an error. Oh, 0, 1, 2. 0, 1, 2. Sharon fruit. I think that's an error. I think we found another fucking error. It's not 5 down. I think we found another error. Tell me I'm wrong. Put S juices 2. Juices 0, 1, 2. And that is number 5. 5 down. There's 5 down. There's not a 5 across. Oh, it got reassigned earlier? Wait. Did it? Oh, I missed that. You got me. I missed it. I missed it too. You got me. Okay, they got me. So juices 2 equals juices 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's blueberry. All right, good. I feel better. Yeah. Print reverse uses 9. Did they fuck with it? No. Okay. Print reverse uses 9. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Blackberry in reverse, beginning with a Y, number 6. So 6 down, 5, 6 down. Yep. Blackberry. Okay. 7. Put S juices 10. Also not fucks with. Oh, wait. Is there juices 8 anywhere in here? Look at this. We got 3 wrong. I would have got 3 wrong. 3 wrong. Put an A. Juices 8 equals A. So 3. I got 3 wrong. 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. I would have put strawberry for 3. And it would have been wrong. Wait. No, that's juices 9. That's juices 9. Oh, here we go. Print reverse juices 9. Wait. No. That would be juices 8 equals A. I still think there's a problem here. After Alec. Oh, right. Yes, this is going to blow up. This would blow up. This would blow up. Tell me I'm wrong. This is going to blow up. This is a problem. Wait, no, never mind. Because it put the pointer in there. Okay, so never mind. See, so A is a pointer to something. Juices 2, it puts the pointer to juices 2. So 0, I'm probably glad I did this. Juices 2, so 0, 1, 2. So that's pointing to Sharon fruit. Sharon fruit is now in A. And then juices A becomes Sharon fruit, a pointer to Sharon fruit. So juices 8 becomes a pointer to Sharon fruit. So that means put S juices 8 becomes sharing fruit, which is number 3. And when that becomes sharing fruit. Okay, got it. Yeah. Did we ever get liver working with Terraform? No. We're going to change it. Yeah, we're going to talk about that after this. We can talk during the break in like 10 minutes if you want. But otherwise, we're going to, at 4 or 5, I'm going to be doing all that stuff. I'm just going to do it on a separate machine. I'm not going to use the libvirt driver. I'm going to use SSH as the driver. Because then the code I write will use a different provider, and I don't have to fuck with the provider in Terraform. I can use the same provider I would use for my cluster on a separate system using SSH. So that does a lot of things. All right, so put S7. We almost threw this. So 7 down is juices 10. They didn't mess with juices 10. So 7 is, so it's 0, 1, 2. Let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Starfruit. So starfruit should be 7. 7 down should be starfruit. Yep. 8 print reverse juices 1. 1 is original. 0, 1 waterberry in reverse. In reverse. Waterberry in reverse. That means Y first on that. Uh-oh. We got that one wrong. Did they mess with 1? 0, 1. Waterberry. Print reverse. Juices 1. 0, 1. Hit the snacks. Yes. Have fun, guys. See you. 0, 1. Yeah, if you need to take a break. 0, 1 is waterberry. Waterberry's juices 1. 0, 1. It should be waterberry. Did we change juices 1? In step 6. Print reverse. Oh, we had something happen right here that I missed. Okay. So juices 1 equals juices 3. 0, 1, 2, 3. Ugly fruit. So print reverses, so it should be T at the top and then ugly fruit. So that is 7 down. Oh, no, 8 down. Yeah, 8 down. Not this one. Okay. Yay. All right. I mean, I had to think about it, but we got it. It is pretty silly, but you know what? It's good. And here's the answer. Your C toolbox. Hey, I think we're done with chapter 2.5. This is great. We'll be on to chapter 3. Your C toolbox. You've got chapter 2.5 under your belt, and now you've added strings to your toolbox. For a couple lists of tooltips in the book, see appendix blah. The string H header contains useful string functions. Yes, an array of strings is an array of arrays. You create an array of arrays using char strings blah blah blah. Although, you know, I don't like that way we talk about it. String CMP compares to strings. We learned all of these. I don't want to talk about all the functions. We got all of those. So, ta-da! We are on chapter 3. Put a bookmark in it. Let's a code like this, I would personally kick them. Yeah, I know. Why would you do that, right? Just to be silly. I know. It's just, yeah, it's trying to keep it fun. We got 14 minutes till the next. So let's at least read this. We're gonna read up to where the next code is. So let's read chapter 3 here. And thank you for that. So every operating system includes small tools. Small tools written in C perform specialized small tasks such as reading and writing files, filtering data. If you want to perform more complex tasks, you can even link several tools together. But how are these small tools built? In this chapter, you'll look at the building blocks to create the small tools. You'll learn how to control command line options, how to manage streams of information redirection, getting tooled up into no time. So this is going to, I have a feeling this is going to cover Unix philosophy. Yeah, it's going to cover input, output, taking, writing to files and tools and things like that. That's stuff you probably have covered in another language already, so this would be interesting. Small tools can solve big problems. A small tool in C that does one task and does it well. Hey, sounds like the Unix philosophy, right? Yeah, it's also one of the solid principles if you've done that. So there's actually, people always leave off the rest of the Unix philosophy. It's very important that we not do that. So the actual Unix philosophy, which you can go look up, is do one thing and do it well. and make sure it integrates well. So that's there. There's a professor from Oxford has a great YouTube video on that. There's actually 4 parts, but those are the 2 parts, the 2 main ones. So it doesn't. Well, if you want to, you can go look at it. Let's actually read it. Why don't we do that? What is the Unix philosophy? It's in the name of the chapter. Do one thing and do it well. Yes, but it's more than that, right? Fun. You did? Nice. Fantastic. The original documentation of Unix philosophy by Douglas McIlroy. Yes, absolutely. And that's really a worth a read if you want to go read it. Unix philosophy originated by Ken Thompson's set of cultural norms and philosophical approach to minimalism. I don't even think it came from Ken. It is basic experience in lead developers. Let's go read this one. Do Java. Doug McIlroy on Unix programming. Actually, Doug's is better. So here it is. I think this is as documented by Doug. So that means Ken I think is the originator, but Doug documented it. We're going to go one further on this chapter and talk about the Unix philosophy. We talk about this a lot in the boost too. Make each program do one thing well. To do a new job. By the way, a reminder that C was invented to create Unix. I'm going to say that again. The most powerful, most amazing operating system ever invented on planet Earth, the Unix operating system, was first written in assembly by Ken Thompson. And it was too hard to write it in assembly. So they made a language. Dan Ritchie, Kenneth Thompson, Rob Pike was, I think, a kid at the time, an intern in the group. They made C. They constructed the language C in order to create the Unix system, which is the basis of Linux and everything else that came from that time. It actually changed everything, the whole Unix philosophy. So I want to say that because people love to throw C under the, to put a mud on C and stuff. Solaris was all, some assembly sprinkled in. Yeah. Solaris was not all Java. What are you talking about? Make sure they know you're joking, because that's very, very sarcastic comment there. That is not true. So make each program do one thing well. To do a new job, build afresh rather than complicate old programs by adding new features. So don't add monoliths. You can probably think of a lot of things right now that don't do that. I'm sure you can think of at least one application that does too much, and it's not the Unix philosophy. In fact, that's why VI is better than Emacs. Emacs does not do this. People love it. I'm not, use what you want, but it doesn't follow the Unix philosophy, and they don't even try to. Expect the output of every program to become the input of another. This is called a filter. And as yet an unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive input. Design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts. Use tools in preference to unskilled people to help lighten the programming task, even if you have a detour. Now, so here's another variation on it. Here it goes. Where is it? All right. Yeah, here we go. So here's here we go. Doug McIlroy in Unix programming. In the Unix programming book, he's with Dennis Ritchie, they said, this is the Unix philosophy. Write programs that do one thing well, and write programs that work together. Now, programs that work together means, using text streams and filters and stuff. I just realized people drop that part of the Unix philosophy all the time, that it's focused on text streams because text is universal interface. This is the Unix philosophy, and it has dominated. It's really powerful, and discarding Unix philosophy unnecessarily is kind of stupid, actually. So, when you read in a book about C, again, C was written. C, the language created to create Unix. A small tool in a C program that does one task and does it well. it might display a content of a file to the screen or process is running, etc., etc. You had something like Zig or Rust at the time. Yeah, who knows? But they back then they had to make it all to make it. People see Pong and they're like, oh my God, that's such a stupid game. Yeah, you know what? They actually did that with electronics without assembly. So yeah, next time you can make a Pong game using nothing but electronics. Good with that. Good on you for that. I can make Pong in 10 minutes. Yeah, right. Do it with just electronics. A small tool does one task and does it well. Operating systems like Linux are mostly made up of hundreds of small tools. You probably should say Unix there, because Linux is the child of Unix, pretty much. Someone's written me a map web application. I'd love to publish my route data within it. Trouble is the format of the data coming in from my GPS is wrong. This is data from the Cyclist GPS. It's a comma separated format. It's actually not. It's comma delimited. CSV has a very specific purpose and meaning, and it has quoting and stuff like that. This is not. This is comma delimited. This is latitude. This is longitude. Okay, equals 21. This is the data format. Boom, 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 boom. The data is the same, but the format's a little different because now it's like this is actually kind of like JSON. It's not. Yeah. This is JavaScript code. Yeah. It is. Is ESR art of Unix programming? Yeah. Yeah, Eric. I haven't read that one yet, but I probably should. This is not JSON JavaScript. No, it isn't. It's valid JSON code, but it is not. This is actually not JSON. If one small part of your program needs to convert data from one format to another, that's the perfect kind of task for a small tool. Converting data from one format to another, otherwise known as a filter, is the basis of Unix. And I do this all the time. By using a filter, let me show you. They're just talking about the concept, so I want to show you. I can be editing. This is me. I'm making an edit on a file, right? Because there's a program that's a filter, I have a filter that is called comment. And I can use the filter command, which in VI is the exclamation point. And I can do it twice real fast to send the current line to a filter. And that's what the exclamation point, the dot exclamation point like that, that's the filter command of VI that says send the current line or however many lines to the filter program and replace those lines with the output of that program. That's a filter, a Unix filter. So if I say CMT, which is a tiny little program that just inserts a comment character in front and then outputs that, then I can do that and I can transform that line that way. You can use filters for all kinds of things. So let's say I have a header, right? And I can write a little program that takes in that line, adds, calculates how wide it is and everything, and puts a line at the beginning and the front of it. So I can use a filter here. Same thing, filter command, and I can call it htitle. That's the name of my filter command. It takes in that line and replaces it with the output. And the output is calculated and it centers it and puts it there. So by combining a bunch of little filter commands, subcommands, tools, whatever you want to call them, you can create all kinds of amazing things and you can tie them together. So like I could say, I don't know why I would, but if I wanted to, I could say, I could comment that and then also pipe it to htitle. And now we'll get something different, right? Now what it did is first of all, it commented it and then it put it through htitle. That's a pipe. So by chaining together filters and Unix commands, you get an extremely powerful way of doing things. It doesn't have to be in your editor. I can do that all from the command line. I could say echo something, pipe that to CMT, and I get something like that. I can pipe that to then htitle, and then I get this. Same exact thing. So this is the power of the Unix philosophy. And that seems to be the starting point of this particular method of chaining standard output and standard in together is very common in Unix. It's the basis of Unix philosophy, and it's an extremely just powerful approach in general. And I can't talk enough about it. All the magic you ever see me do here using the terminal, 90% of it is using some form of this kind of thing. You can curl down the weather from the internet and transform that into something else, et cetera, et cetera. So since they're talking about it, I'm going to talk about it. All right, so we have 3 minutes. Hey, who hasn't taken a code printout on a long ride only to find out it soon becomes unreadable? Yeah. We all know about that. Sure, we all have. But with that thought, you should be able to piece together the original version of some code. This program can read comma separated data from the command line and then display it in JSON format. Okay, so first of all, this is not JSON. It's very close to JSON, but it's not JSON. And they also haven't taught you JSON. So what we're going to do is, in this particular case, I think you should just write the code and get it to work, and then we'll talk about what the code does, particularly what JSON is, right? And it's gonna help us understand JSON, which is something that comes from JavaScript world, but it's also the basis of like everything in the world. So you kind of want to know it. It's also how I do my Twitch streams. So let me show you one, for example. JSON recursive is cheating. Well done. Yeah, well, we decided recursive is bad because it's slower. Everyone was giving me shit about that the other day. No, YAML's not JSON. So watch, here's something. So I can do live channel. This is a command that goes out to the Twitch. This fetches the Twitch JSON data for my Twitch channel, and it gives back the data that is associated with this channel. There's a Unicode character. And as you can see, this is JSON data. So it's really important that you learn JSON and structured data. It seems like they're introducing it in this chapter, so I'm just going to mention it. And so you have, this is an array, and this is a key value hashed pair, which is something that does not exist in C by default, but I imagine they're going to get to that, and we're going to talk about how to make one. If you've used dictionaries in Python, you know what I'm talking about. If you've used objects in JavaScript, you know what I'm talking about. If you've used maps in Go, that's what we're talking about. So this is JSON data. And if you want to talk to the YouTube API, you want to talk to Twitch API, you want to talk to the weather API, you want to talk to banks, all of them speak JSON. They don't have you make a hash table and seriously only link lists and binary trees. Okay, good. But they're at least having us use JSON data here. So yeah, there's JSON all over. I use JSON to store the status. It's kind of, you can almost use it like a database. You can also combine this data with a program called JQ. This is the filter approach, right? And you can say, look, I only want to get out my broadcaster ID. So I could do this. I could say, all right, I want .data. So data has multiple items. So I want data 0. I want a data item 0. And then I want the broadcaster ID. And that'll just give me the ID. And if I want to get rid of the quotes, I can just do -R for raw. JQ is, like I said, so I can pull that thing right out of there. If I wanted to change it and I wanted to make it into a title, I can put the title here. I can grab the title, and you see what I mean. You can use this to convert data back and forth. No, they converted it. They converted it. Yeah, because see here, they didn't convert this one, but they convert this one. For some reason, they convert the game IDs, but they don't convert the titles. I cannot figure that out. Because Unicode characters are valid JSON values, and converting them is stupid. But for some reason, they did that a long time ago, and it's kind of stuck. It's 2:01, so we're officially on break. I'm actually going to take my break today. This one, I'm going to go all the way full 15 minutes. So if you want to get started coding in this project, go for it. And when we come back, that's what I'll be doing, and we'll see where we go from there. So I'm going to go ahead and put myself on break. I say back at 2:15, and we're still going to we're going to go all the way till 4 today. So we still have plenty of time, but go ahead and take your break. I wrote all those customized utilities in Bash. Yeah, here's my dot files. You can go look through my scripts. You can see them all. So here's H title. Bash is my favorite language because I can give it so easily. Oh, sorry, that was wrong. I should have went and give H title instead. So there's H title. I don't know about live. Give her CMD live. That's my repo that's got my live command in it. You just check on my GitHub. You should be able to find all that stuff. Yeah. So CMT, give CMT. It says CMT. Yeah. See this? That's all it is. That's all the commenting one is. People will use like sed and awk and shit in there. You don't need it. You don't. You do not need it. All right. So I'll be back. All right. So, what have we got next? I think we got some more code coming. Here we go. How many of you got this code? How's it going, Hennessy? Let's jump right into this one. So let's call this what should we call it? Pocket code. Well, sure we have all have, but let's build a thought you should be able to piece together older version of some code. We're saying scanf stands for more than one piece of data. Okay. Give me every character up to the end of the line. Yep. What the hell? Not, 70. Oh, I didn't know you could do that with scanf. 79 things that are not a line return. What? That's cool. What will these values return? Always uses pointers. This has got to be latitude. This has got to be longitude. And this has got to be the info. What are we naming this? Geo something. Geodat. What should we call it? Geo info. Let's call it geo info or something. As chapter 3. Nice. Chapter 3. I'm going to call it make directory geo info. We can call it long lat. How about that? Long lat it is. Long lat VI make file all long lat. We're going to do long lat.c include stud IO. STDs stud is easier. Main, let's see, int main, and we'll do a return 0. Hey, hi there. Return 0 it is. And then what? Return. Let's go back to the thing. What do they want us to do? They want us to input data if we've started. If started, print control N. Otherwise, be careful how you set started. We can't use booleans, right? Because we don't have that. So we can set it to 0 or 1, right? So this is just going to scan. Okay, so this is going to scan a lot of data. This is going to scan the data from a file or input, and it's going to print out the data in a different way. So this is going to parse or scan. Parsing is sometimes called scanning. If you ever write an actual compiler, you'll learn all about parsing and scanning and tokenizing and lexing and lexemes and all that stuff. Those are all, some of them are synonyms. And you'll learn all about that. But that's where the term scan comes from, right? To a beginner, the term scan might seem weird, but what it's like, you can think of it as like scanning the letters as you go, and then having them do the right thing. So that's what we're doing here. This is actually a parser that's scanning through. This program is actually a parser. So let's actually write it as such. I'm going to rename it because of that. I'm going to move along that to parse geo. ParseGeo. How about that? ParseGeo is my new name. It is. We're literally writing a parser, and God knows I love parsers. I wrote pagan.dev, which is a take on the peg parser. I love that project. I mean, that's the one thing I do geek out on coding is parsing. I really, really love it. So because I like transforming, stuff, and that's what filters and parsing are about. That's what this chapter is about. So, parse geo.c. So let's go to it. Yeah, parse. We could actually write this part of it and call this function parse, but we're just going to go ahead and make it into a filter. All right, so what are the things that we're going to be reading in our filter? We're going to read longitude, latitude, and the info. Those are the main fields of input. And we can actually do test-driven development on this if we wanted to. And if you work with text, yeah, you run it no matter what, you're going to be, that's why regular expressions are so fun, right? So longitude and latitude are both floats. Those are really long numbers that have dotted notation that use the floating point processor. Fun fact, once upon a time, you could buy a computer with or without floating point mathematics in the 90s. Yeah. If you had extra money, you could buy a computer with a floating point processor. You pay an extra $300. Nowadays, selling a computer without a floating point processor is ridiculous. It's like you wouldn't even think of it. But back then, everything was an integer, and that's actually why shell scripting, most of it, Z shell is the exception, does not do floating point arithmetic. You have to use a tool for that. And usually the tool is BC, and we'll talk about that in the boost. A math coprocessor, it's true. Some of the old farts in here might actually remember those days. So long, we're going to do long, and long lat. Fun fact, if you're doing this with Go, you could just do this. Put them on the same line, but you can't do that in C. We don't need to initialize it with a value. The default value will be 0 automatically. And we need to declare our info. So it'll be a character array. Our info will be an 80 character. That means it can be up to 79 total characters with the 80th character being a null. What's that? You cannot what? I don't think you can. You cannot do that in C, no. Farther, no. I mean, we could try. I ran circles around my friends. Really? Interesting. You should be able to do one line with long lat. Really? You can? Well, why are we doing it that way then? Okay, I learned something today. I thought that was a C only. I mean, I thought that was a Go only thing. Nice to know. All right, so we're going to declare those on the same line. Let's just see if our code compiles. This is always a good test to see. I think it's, yeah, oh, doesn't like it. It's just saying it's not used, which is a nice warning. To upgrade it to 2 megabytes with a handful of ICs instead of buying a 387 Pro processor. Really? Wow. Interesting. All right, so started is essentially a Boolean. We don't have those as true or false, so we're going to use 0 or 1. So started. Has it started yet? No. So we're going to set it to 0 as or false. Put as date. So this is just going to print out the initial stuff from the program. You know, it sounds like this wants to convert it. It's doing some sort of file conversion. I don't like that it's not doing it as JSON data. It is not printing JSON data. Let me just be really clear here. It can read comma separated data and display it in JSON format. This is not fucking JSON format. How dare they? This is wrong. There's a library for Boolean. I know. Yeah. Yeah, I'm not using it, but you could use the. We could. You know what? We already know about libraries, so maybe we should jump ahead. Include bool.h, right? If you do that, then you can actually do started equals true, right? Or you can use a thing. It doesn't matter. False. So let's try that. This program is lying to you. This is not JSON data. How would they even get away with calling this JSON data? Unsigned short. What? Can I declare it as a bool? I think we can do that instead, right? Let's do that instead. Yeah. This is kind of annoying me. This is definitely errata. Where is the errata page? This is not JSON data. Okay, we're gonna fix this to do it right. This is their boomer is showing. Their C boomer is showing the authors of this. This is definitely not JSON data. All right, so if you want JSON data, as I already showed you, we need to have it be. First of all, we need to have it be inside of a map if they're going to do it. So we're going to do this. We're going to fix their error. We're going to fix it. You have to have all of your stuff, your keys, surrounded with, and there's this is JavaScript data, but it is not JSON data. So we will have it be, it uses colons too, and we'll have this be a bracket, right? Now we're going to put something on the end. So let's go ahead and do that now so we don't forget. I'm going to say, so at the end of it, the data is an array, and we actually don't need data like that if we don't want. But let's do that. So here we could say, we could close up 1, 2. So we make this closing thing here. And then on its own line, we could put a bracket, and that should work. Let's go ahead and compile that. Bool. There's no such file, or no such bool. What did I do wrong? There's no such bool. Let's just use what they did. Well, int, unsigned int, unsigned int, unsigned short. That's tiny. It makes it tinier. That makes it a nice tiny int. All right, so is it standard bool? I didn't know that was it. Include bool.h. Yeah. I like it because we can just do it. Bool. Hey, hi there. So let's do, let's say false. No, true, false. Everything starts with stud. Was stud. It didn't used to. At least that's what I remember. Uh-oh. Unused variable lat. Fine. Fine. Another unused variable. How's it going, Robin? Make. All right, so parse geo. So that's actually JSON data. There's nothing in it, but that's how JSON data is written. We're gonna go back to this project. We don't need string.h just yet, I don't think. I don't think we're gonna be doing string length or anything. I don't know yet. We're gonna find out. So we got our put s there. Does it still work? Yeah, it's because it's just printing stuff out. Oh, string h without std? I did. Is that even a thing? No. That's probably predates all the other stuff, you know. I mean, we're kind of, you know, outside of bounds. That's not something in the book, but all right. So while scanf, this is the important thing, right? We want to scan one line. So let's actually just do one at a time. So scanf, we're going to scan all this stuff in. So scanf, we're going to scan in, and what do we want? We're going to scan in a float, right? And then I think another comma. Yep. We want a comma, and then another float with no white space. You can't do white space. And then we want the info. And the info, we could say, you know, 79 characters, right? Or we could actually trim it. Instead of saying 79 characters, we could say 79 characters except for line return. And this is kind of a cool trick that I'm sure they wanted to use earlier in the book and forgot to. Says 79 of any set of characters that is not, then that, I didn't know you could do that, which I think is really cool. This is actually a regular expression set, and that there's two brackets to go around it. The caret means not. So it means any, that says 79 of anything that does not match the set of characters within here, and this means \n. Unfortunately, we should probably put \r in there as well, because carriage return, line return is sometimes what's used instead of just \n, and that would ruin your day if you're on a Windows machine, which does carriage return. I think they all do carriage line return now, but that used to be a way to get that. You may get those line endings occasionally that are that way, so just make sure you put both of those in there. That I think is also a bug in the book personally. And so then we're going to say I want to read in lon, lat, and info. Info is 80, which leaves room for 79 characters plus some other stuff. And otherwise it'll chop it off, right? So in the last character is either going to be a carriage return or a line return, in which case we'll be good to go. So let's actually print that then. Let's do our conversion. So they want latitude, longitude, and info. So let's do that. So printf. So we're doing, again, they want JSON, which they are not doing. So we're going to actually indent our JSON as well. We're going to indent it 2 spaces and then another 2 because it's in the array. Float to long. Oh, right. You're right. Sorry about that. Thank you for catching that. But all of them, of course, yes. Yeah, I'm guessing. I have no idea. So 1, 2, 1, 2. So we're only doing 2 space indent, and then our JSON data. So we'll have our first one is going to be latitude. I don't know why you would type all of that out. That's stupid. Let's just do lat. And then a colon. And they're putting spaces in there too. I mean, that's normally not done, but whatever. You can do, we'll make it readable. So the latitude is a number, so we can actually have it be a number. Yeah, floating point numbers count as numbers, so they don't need to be quoted in JSON. So we have latitude. Let's just try the latitude first and see if it works. And we'll put a \n there. Let's try, well, let's just do lon first. We're going to build it up as we go. So make, I broke something. Lon, lat, double. What did I do wrong? 2, we have a float. What? Interesting. That's interesting. The book didn't catch that, so we have a new error. This is good. I want to know. Oh, it's because we scanned. Lat is used uninitialized in this function. Okay, what about this one? Format expects argument of type float pointer, but the argument 3 has type double. Interesting. Error, this is new errors. Expects an argument of type float pointer, but argument has type double. Interesting. So I'm learning something here. I don't know if it's because it's on, I mean, you guys were telling me that's not an issue. Huh. It's a pointer to a float. That's type double. Huh. That's another bug. There's a lot of bugs in this. We keep running into bugs. It's kind of annoying. Yeah. Scanf. I mean, do we need to initialize this too? That'll get rid of the other errors, right? Yeah. And because you didn't specify the type in the 3 format string. No, that's not even an error. So the error is because of incompatible types. Which is really weird to me. Format F expects an argument of type float pointer, but argument 2 has type double. Do I have to put the pointer to it? I thought it did the pointer to it automatically. Oh, you're right. I have to dereference it probably. I see what you're saying. I do. I didn't think we had to dereference it. Yeah. I didn't realize we had to dereference it for scanf. That says put it into that stuff. And info is a pointer though. Yeah, info is already a pointer and those are not. Interesting. Interesting. Yeah. I'm really glad I hit that error. That really helps me. You know why? We haven't needed to dereference all the other stuff because we've been doing the implicit pointer shit from this for the whole character array thing. And this one, and so this is forcing us to use an actual pointer to a value, right? Now we could have done this, but then it wouldn't have initialized the space or declared it. So we can't do that. We have to initialize the value. In fact, I don't even think you don't have to initialize values, I suppose, if you use the pointer. So let's go back to this now. That should work. It did give us a warning. I did. So, okay, so that's happier now. Thank God. Okay, so parse geo. What the hell? Parse geo data. Oh, it's waiting for us to put data in. So let's give it some data. Let's give it a number and another number and then something here. I cheated there, so just in case you guys know. This is the same as if I had typed it in. That's all it does. That's a bash thing. So we got our latitude. And normally we put a line right here. I'm going to separate this up. I'm going to put lat. What goes first? Longitude, latitude? Longitude goes first. Lat. And we'll do info. It really doesn't matter. It's C. It's going to do it really kick-ass fast. So this is S. And we'll get rid of that trailing. No, that should be fine. These two, however, have to have commas after them to be JSON. So you're going to see the output here. We're going to do the output properly. And let's try that. So make, all right, where's my code? So there we go. We have the data. In fact, to make it a proper JSON, thing, we should probably put a line return here. That's customary. So let's try that. Yep. So there we go. Data. Use tabs because it's JSON. JSON doesn't allow tabs. It's illegal data. So as far as I know, tabs and line returns are illegal data in any JSON file. That's why JSON is not as nice as YAML sometimes, because YAML allows line returns. That's because they want to be able to parse it. Like, fine. Yeah. Info should be quoted. Oh, right, because it's a thing, right? It's a string. So now there's actually in Go there's a queue that will automatically quote and escape everything that's in there. We are taking a huge chance here because this is actually not valid JSON data. What happens if this is a bug. Assume no info with quote. That I want to put that there because this code is wrong. The book is wrong on this. The book is very wrong on this. The book is having you write JSON data, but the format that they have you write is not JSON. It's valid JavaScript, but it is not JSON. So don't anyone make that mistake. And obviously the problem here is what happens if I do this, which is totally valid JSON. Well, first of all, it only read the first up to the first white space. So that's already a problem. You guys seeing that? Actually, I think that's my problem. It is my problem. That's my bad. There we go. But do you see what that did? That is wrong. That is wrong. Now, if you want to do it right, let's make it was bash. Yeah, sorry, that was my bad. I feel dumb about that one. All right, so let's go. So we're gonna do something else. We're gonna, instead of doing info, we're gonna quote it. Okay, so what can we do here, right? Custom quote function. Yeah, we're going to do it like that. We're going to fix the book's big egregious error here. This is not JSON. So we're going to say, we're going to do the minimal conversion of JSON data. We're going to say we're going to say JSON if I, and this will return what will this return? This will return a character string. Yep. And we'll take in a string. So we're taking a str, and we're going to return a string, a character string. I think we have to do that. Return a new, right? So, and then we're going to do new equals chart new. I mean, we know it's going to be 80. It's going to be no bit more than 80. So otherwise we'd be doing malloc and shit. So we're going to cheat here. This is totally cheating. If you wanted to do max string, you could put that here and then do that. Let's do that. So define max string 80, and then you could do max string if you want that kind of thing, you know, to not be an issue, max string. So then we could say, so we're going to make a new buffer. The problem with this is we could very easily push the string past the buffer limit by doing the quoting. And if we do that, what's it going to do, right? For such kind of function instead of character pointer. You think it's better to return a constant? Okay. Constant character. Okay, good. So this is not something I was anticipating doing. We're going to hit in C. You're going to hit problems you wouldn't hit in other languages. Like what happens if we? Okay, so let's assume that max quoted. Let's assume that every single character has to be quoted. That means the max quoted is 90. Right? So this, I mean, sorry, it's 160. Because it's double the size. I mean, it's one less than that, but you know. So, you know. So we can do max quoted. And then what can we do? We can use string. Include string. .h. And now we can just do, I mean, this is a hard way to do it, but we could just do a substring replacement. String replace, right? So let's look that up. Man, str, was it r replace character? No, that's not it. Actually, the JSON fee will be short. Added \I, yes. Well, we're not going to add the quote in it. We could. And that would be the right way to do it, right? We could do, I don't know. I mean, I'm really having a hard time not writing my own scanner here, because we should probably scan every character in the character array and say, are you a quote? If so, don't print the quote. Do you know what I mean? And build it up. and build it up and say, you know, character number 1 equals, we can append and make our own one. I mean, that would be the fastest way to do it, but that's like a lot of extra code. I don't know if I want to do it. Do you know what I'm saying? Like, isn't there a string replace already that does it? You know what? That's the fastest way. So let's do it. I don't care. I mean, it's definitely the fastest. All right. So what can we do? We can say for, all right. So I'm going to write the algorithm. So to do, we're going to say, loop through every character in the string, and if the character is a double quote or a line return, look, JSON actually has a lot more than that. Built-in string replace, that's too advanced for C. Is a double quote or a line return, then replace with the escaped JSON equivalent. And I've done this in other languages. There's actually a lot more characters that need to be escaped. So tab would have to be escaped. Unicode, however, does not have to be escaped. I might have stuff on this. Pagan Go. I wrote some stuff on this once upon a time. Spec, license classes, doc. So we go to the ASTs. Doc. Assets. I know I'm kind of off the rails here, people. No, that was the documentation. Tokens. I made some samples. There we go. So AST. I made some samples of it. I'm trying to find them. I implemented all of JSON using it. Grammars, that's it. So here's the official grammar for JSON. I documented the official grammar in Pagan, which is my own language. Did you do it already? So this is the actual grammar for JSON. So written in Pagan, which is my own meta language based on Peg. And this says, so the stuff that has to be escaped, you have a map, you have objects, numbers, strings. So these numbers get escaped. So that would be line return and tab, I'm pretty sure. Here you go, escaped. So backspace, line feed, carriage return, no, sorry, line return, carriage return, tabs, and Unicode are escaped if you need to do them. They don't have to be escaped, but they can. Double quote gets escaped, and backslash gets escaped, and slash. Those all get escaped. So if we were going to do this right, that's how we would do all of them. PEG is Parsing Expression Grammar by Brian Ford. It's a parser that assumes infinite look ahead instead of single automata context-free grammars. So it's not a context-free grammar. It's a modern grammar for a modern time with unlimited memory. I really suggest you look at it if you're into parsing. I got into it so much that I including Guido van Rossum got obsessed with PEG. He was redoing the Python 3 parser as a PEG grammar. If you want to know more about PEG in general and parsing, which I fucking love, you can go read pegin.dev, and that's the one I wrote. We wrote kind of a quick and dirty functional parser based on the Haskell functional parser approach. For that, we still need to improve that. Pegin actually is a better than regular expression way of expressing structured domain languages and things, which is why I wrote it, because I wanted to write my own sub-languages really quickly and apply this to them. And I learned the technique from watching the guy who made Express, that's the E in the MERN stack, TJ Hollowaychuk, used PEG to create a domain language for his Apex log programming interface REPL. And from that, and I've contributed to the Go PEG projects as well. So parsing is your thing. And then, so you can read about the thing there. That's kind of a side tangent, a side quest if you want to get into parsing. If you're going to get into C and parsing and stuff like that, you need to learn meta languages, including A, B, and F, E, B, and F, which is the common one for indicating syntax of a language. A, B, and F is commonly used for RFCs to define how TCP/IP talks on the network, etc. And those, there's, and then, plain old BNF, Bacchus-Nauer form, which nobody uses anymore. They use either ABNF or EBNF. But these days, everybody uses PEG because PEG is far more powerful at expressing things, and it's more efficient than Lex and Yak and stuff like that. So I'm sorry, forgive that for the beginners, but that's just a kind of a self-indulgent, dive into parsing. So I did that because I wanted to write my own markdown parser that was more efficient and created an AST, which is the abstract syntax tree in between. That was in pure JSON. It was really, really terse so that it could be communicated over the wire easily and stored and cached in a way that could make universal translation between any two grammars, so provided that one was a subset of the other. Really, 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 really fun stuff. I like it because it goes along with linguistics, my obsession with that kind of thing. So if you want to do any of that at some point, I don't know when and where I'll ever get to time to work on PEG again. Quint has been really diligent in helping me with it. He's implemented PEG in production at his work, Pegin, and we need to make logos and stuff. If anybody really wants to get into that, let me know. But I pulled this up mostly because I wanted to show you the JSON RFC. This is the exact syntax for JSON captured in one file. This is exactly what's valid. And, we kind of got stuck on this because this calls this thing that they do JSON. It's not fucking JSON. It's not even close. It's valid JavaScript, but it is not JSON. That is a lie, and it pisses me off because I'm the kind of guy that would write a specification in Pegin just to show what it actually is. Using this, by the way, you can validate any JSON code to see if it's really JSON by running it through the Pegin linter and doing that. So I know how to parse JSON, and I'm trying to figure out what we're doing here. It makes me feel dirty because we're only escaping two characters. We're escaping the double quote and the line return, which I don't even think we should add. I think we should just let's just say about this. Let's change this. This is making me happier. Escape D quotes. That's all. That makes me feel much better because it's not lying, So let's do this. And then down here we would say escape D quotes and because it's not JSON. Come on, let's be real. All right, so escape D quotes. So this is not in the book, but I feel like it's important. We have 5 minutes to the break. I might work through the break on this one, but that's up to you. So how do we do this? Well, we have to go through every freaking character. We do. We have to go through every character and build up a new string that's potentially quoted. The size of the potential string must be at least double the total size of the string, because it's possible that every single character is a quote. So we have to give it that much space. So then we do the loop, right? And then we do, I think we could do string length here. So we do, was it size T, length of str equals string lang. I don't even think we need to do that, actually. We could just go for the null, can't we? So this is super, super dangerous. Assume terminated with null. By putting that in there, like so many other programs do, which is, this is where you get dangerous, right? 'Cause somebody passes me a pointer to something that doesn't null terminated, we're kind of screwed, right? But the max quote thing is gonna save us. So or the max string thing is gonna save us. So we can do this. We could say, I like while loops, but I mean, let's start with a while loop. So let's just start while true. I like while true loops. Screw me. I mean, we can do it another way, but, and then we're gonna exit, right? And see, strings are always 0 to it. I think they are, but it's assuming that they are. We're making the assumption. I want people to know that we're making that assumption. So if somebody passes something that's not null terminated, they pass a pointer to character array that's not null terminated, you're fucked. And there is no type of string that would, you know, ensure that. So that kind of makes me uncomfortable. Wouldn't we assume? The difference with string lang is that string lang actually iterates over the whole string. So we're iterating over the whole string twice just to get the length. Once to get the length and once to do the escape. So in our case, we're going to bypass that and we're just going to iterate it once. You see what I mean? If you look at the source code for string lang, somebody told us about that the other day. String lang, literally, that's what it does. It counts every character and gets to the null and says, hey, here's how many you have. Well, since we have to iterate anyway over every character, we can bypass that. Right, Frank? 10xer? So if we do, so we're going to do that. We're going to say while true, and then we're just going to, actually, no. All we have to say is while, we could get the first character. Let's say char current equals, we could do str. Are they gonna let me do that? Or are they gonna yell at me? So we could say while char, we can use pointer. We're using pointer math, and then we could say while c, is it pointer string? Thank you. So so then we could say while c does not. Am I starting to get c like in my writing? See, I normally I'm getting out of my go here. So then we do c. So we could say while c. I think we could just say c, because if c is null, actually, yeah, if c is null, wait, if c is null, it will be false, right? So that's a C trick that I was unaware of until last week or so. And then we do C++. So it says, so, you know, when is C false? C is false when it's null. This would be a for loop. Oh, right. Duh. Yeah. Of course that's a for loop. So that's going to iterate over every one until it gets to the end. Now, every time it gets to a new one, we can add to. Now, this is going to be tricky for me because I don't know how to append to. I guess the memory space has already been allocated, so I don't have to use append like I'm used to using in other programming languages. The memory has already been allocated for this big ass thing that's double the size, which is going to be a waste, but oh well. Oh wow, we could do. Wait. Holy shit! Can I really just do that? Yeah. So that's just going to add one to it. I don't even need this then, do I? A non-bill pointer to zero null value is not false. Otherwise, another foocan. A pointer to a non-zero null value is not false. A non-nil pointer. Yeah. I don't think I need C here. No, C is the value pointed at. So we need to do string plus plus. And I also need to do C equals the next one, right? Don't I have to do C equals string plus plus? I think you can do that. This is the same as a for loop. I like that. Let's try that. So while that's cool. That's such a C thing. I would never have thought of that on my own. So that says while the string pointer is not null, is your pointer or is it copied? No, I'm not going to change it. I'm not going to change it. I just want to go over. I'm going to build a new array, a string array. You see what I mean? So now we can just do that. Yeah, I see what you're saying. Okay, so god damn, that's so cool. I understand that for the first time. I see what that's doing. Char C while C equals a point pointer. Oh, does that do the character array? Do you need to do while C equals a, it's really you increment the pointer and test the value pointed by string. I can sense a use after free coming, guys. Yes. Yeah. Yeah. I mean, this is interesting. This is scary for me. So all I really want to do. Wait. Okay. I have another question. If I return, there's not going to be a free here at all, is there? Yeah. You need to get a value from string before the plus plus. You think so? Before plus plus. So, all right, let's try this. So character, I don't do this shit. So, and this isn't in the book. So thank you for your help. So char C is just a plain old character, and then we do C equals, and it gives me the value, and then it increments it by 1 on every iteration. And since that evaluates to C, if it's a 0, that becomes false. As a character you quoted, right? And I see what you're saying within memory freed. We're going to be returning a constant that then can be used, but the original string value is still going to be present as well. Search C equals string plus plus. I think you can do both of these. I think you can do both in one line. You can also do it with 4. Yeah. Yeah. I think this is the same as what Tim just typed. We're going to find out. Because I think that this evaluate, I know this is really dense. This is one of those bad C things. I think it's very dense. So C's been evaluated. So the first thing that happens is we look up whatever the thing that came in is, right? So the very first thing is assignment. So the assignment to C happens, right? If the value of that assignment is, well, no. And after it's assigned, it then adds 1 to the pointer, which then becomes, at the end, it'll be null. But then that's not going to happen until the next assignment. But there's a problem with memory, isn't it? With return value, by the way. Yeah. The memory, this is going to be, memory issue is a different issue. So we do need to free this memory eventually. This is going to be a constant. It's always going to be that amount of memory. But the extra memory off of the end of it is going to be written for permanent. But that's just a return value. You already kind of written off on that anyway, right? Because you're trying to create a new thing. I don't think with post increment you can do pre increment. That's why I wanted to point the use of paren. You could do pre increment similarly. Yes, if you did that, then it would increment it before it evaluated it. First it increments C. Because of postfix, it returns the original value. Then it dereferences. Then it assigns it, and the L value of the assignment is equal to the R value. Okay. And okay, that makes sense. Because if it's saying that's what gets it, but ultimately, I was afraid it was going to do the post later. Yeah, I'm still wondering why I can't use str here. Write it simple instead of smart. I agree. I agree. So, yeah, I'm going to leave this one for consideration. But I want to try, because I'm just curious. So let's try this. All right, so this is the one I would normally want. So every time you do this, equals the pointer to the string. And then we have initialize a character C. Actually, I think we can do the initialization as well. And then we don't even need this, right? And then we would have, yeah, and then can't we just do the str plus plus? Yes. Okay. Yeah. So this starts out with the character C, it sets it to the value, and then after the loop finishes, it increments the pointer, and the next round the C is going to have it, and this will evaluate to null, because it will assign, when it's the last one, the pointer to the str will be pointing to a null value. The null value will be assigned to C. The null value is 0, therefore it's false, and therefore that will cancel the loop before it exits that iteration. Priority versus dereference operator. Oh, I didn't know the plus plus has priority. Yeah, but I would rather not have to memorize the priority. I didn't realize that. So that would mean that this is happening before the dereference, before the assignment. Okay. Well, likely, suffice it to say, this is easier to read, even though that's super cool. So I'm gonna try this one. All right. So we still haven't even built up our new thing yet. And we need to say we're going over time, but whatever. We're supposed to be in break time right now, but I'm kind of like totally into this. You probably need another variable as an index for the new. Yes, we do need that, because we can't just append to it, right? Yeah, and we can't use the pointer reference. I see what you're saying. Yeah, we do. It's just an int, right? So we can say int new I. New I is like the new column one. C will be 0 in the first iteration. No, it won't. No, because this assignment's gonna change the value of C before it gets evaluated, because the evaluation is going to happen first. I think that's what's going to happen. So 2 times for quoted characters. Yes, we definitely do. We're going to have to bump it up. Yep, we definitely are. All right, so now we're going to build it up. This for looks, yeah, it's easier to read. Pointers are hard enough, let alone this little bit of magic where this evaluates to null is already magical enough, and makes it false. That might be, really magical to someone not coming from another language or coming from it. So let's say, then the idea here is we got the thing we're going across, and then we have a new bucket. We have a new bucket of memory, and that's what we gave ourselves here. And we have to deal with freeing that memory and everything later. And God knows I don't know how to do that. But right now we just need a bunch of memory. And the memory needs to be twice the size of the max string. Now I could have done a malloc here, but we don't know about malloc yet, so we're gonna skip that. New will not be in constant memory. It'll be entirely on the stack. it will be gone after the return. You are returning a pointer to freed memory. Yeah, so we don't want a constant then. How we return? So okay, let me make sure I understand the statement. That was briefly talked about in the book, but what you're saying is that the character array, the character array allocation of memory is localized to the stack because it's a local variable. And so that gets written to the stack and gets automatically freed from memory after it leaves the call stack and it goes back to the calling program. That stack memory goes away completely. You pass the output buffer as a parameter. Oh my God. Okay. So there's a number of things that I just understood in that statement that I really want to reiterate to make sure I understand them. Oh, thank you. My wife and I bring each other glasses cleaners when we use them. It's part of our love language. We bring each other coffee too. Stuff. So, okay, so let me just restate. So the reason that's unusual to me, so the first thing to know is that, I mean, I have a question. I'm kind of jumping ahead, but does malloc allocated within a local block also get automatically freed? Or is it only character arrays or arrays in general? The caller will take care of the buffer. I don't know. So malloc goes on the heap and therefore it stays around and has to be manually freed. Oh my God. So many things just clicked for me. I've always wondered, why would you use malloc instead of like localized memory? And that is why. Yeah. And then the buffer will be on the stack and on the caller side. So in this case, we could, I mean, there's probably other ways, but in this case, system calls to get heap memory. I don't know. But in this case, this would be a case for malloc because we could do a malloc on the heap and we could return a pointer to that memory there. But then we'd have to, this is why there's no garbage collection, right? Something else would have to go back and say, okay, you use this for this time being, but you need to free the memory that was used in that moment. Yeah, you'd have to force the caller to free it. And this is what people talk about when they're talking about garbage collection. If you ever hear an argument about garbage collection, non-GC, blah, 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 we're getting into this now by talking about this because this is one of those things that the higher level languages do for you automatically. Understanding of what's going on under the covers. Yeah, particularly if you get into arrays underneath the slices, etc. Yeah. So get to the caller. How is it written to the amount? So we likely crash. So, you know, I want to reiterate again, this is a relatively easy thing that we went to go do. And obviously it's not easy because it's C. All we want to do is replace all the quotes with a backslash in front of the quote. That's it. So it's, I mean, we could do it with calls to the strings library, but it would be inefficient and this is better. So we just have to make sure we deal with memory properly. So this is going to get freed and it's never going to land, anywhere else. Yeah. I mentioned use after free. So this is going to return new and it's not going to be constant. It's going to be completely gone, but how can we get around that? Let me ask the veterans out there because we are definitely out of the book. We are not doing book stuff anymore. How could I do that? What would I do? So far we've talked about malloc and I think malloc is the fix for this. We can just go ahead and finish the exercise as it is, assuming that there's no quotes, but when we come back to it, maybe we can, fix this, you know, and I'm going to put here, fix me, use malloc instead and return something the caller can use instead of local freed memory. I'm really glad I had that because this is a gotcha. This is a foot gun. This is something that a beginner coming to C is definitely going to wonder about. They're going to like, where the fuck did my variable go when they try to return it? That would be so crazy. You could create array on the stack, but in main, then pass the buffer quote. And that, you know what? We see the people do that all the time, right? You could say, okay, I want the quotes. You know what? You know what's cool about that is that would be controlling the size too. Yes, let's try that. I want to do that. Then we don't have to do this at all. We could trace the buffer. You could say d quotes. So you pass it a character, you pass it the main string, and then you pass it we could pass it the input, and then we could have character is the output. So we pass it two buffers, and this is the whole in-out thing, right? They may know how they corrupted memory, and C just hums along. Yeah, well, I should warn you about that. I think it probably should too. Or at least in the name should be changed to. This is more functional. This is interesting because this is actually literally in-out variables, and this is a C thing. This is not something that's common in other languages. You know, they don't do this kind of thing. I think we could actually return void here, or we could return how many things were escaped or whatever, and just have our in-out variables instead. It's a very C approach to it, and so interesting, because then we're just doing the transformation in our little loop here. Our little loop is just doing the transformation. It's not doing anything else, right? And we don't even have to return anything. We just have to make the transformation. Is the opposite of functional? Yeah, I know it's not functional, but well, actually, no. You're absolutely right. This is not functional at all. We are doing a side effect transformation of a thing, and we're only returning whether it worked or not. That is not functional. That's the polar opposite of functional. But this is not functional, but I think we're just okay with that. Address a stack memory issue with local variable buff returned. Yeah. The other thing that's great about this is that the caller has control of how big the buffer is. You know, the other way, we're like, it was really buggy and brittle because we had like maxes elsewhere, right? We don't really even need to set a max anymore because it's up to the caller to decide how much room to put. So we could say 80 here, right? Say I have 80 characters for a string. This is this way. Absolutely. This is why they turn to Go and Rust and higher level languages, because they don't want to deal with all these intricacies. That's why. But I don't want people to think that C is a bad language because of these things. C is just a lower level language. It's the closest to the hardware you can get besides assembly. So these kind of things you're dealing directly with memory issues. This is what C is about. It's not something to be afraid of. It's something to embrace and learn and only use when you have to. You still have to deal with this, but the compiler screams at you. Yeah. So let's go back to, I like where this function is going. I feel so much better. It just feels cleaner already, right? So this changes to in, and we're just going to increment the pointer in, which is a number. And down here, when we do escape quotes, we can actually call that all by itself, and we could say character info, and can we do this? Can we say escaped info would have to be 160 maximum, and I think we could actually do this. I think we could scan the info, and we could say escape dequotes, and we could say info, comma, because actually, do we have to take a pointer to the info? No, it'll pass the pointer automatically because it'll deprecate it, but we won't have size of anymore because of pointer decay, and then and escaped info, and that's kind of an in-out situation going on. And then down here, we should be able to put escaped info. I'm kind of geeking out on this. I'm blowing right past my break. I'm sorry, everybody. I see, but much more difficult to shoot yourself in the foot. Yeah, and this is why people like Rust. And, you know, for that reason, I don't dislike Rust. The thing I dislike about Rust is the syntax. But, you know, I don't know that C is better, right? If you had to pick between C and Rust to write a complex application, that's a tough question. And this is why people that are turning to Rust, but they're replacing Rust. So see, the people that are replacing JavaScript with Rust, to me, that's a different issue. It will crash now or by default set out to null. Yeah, it's not done, right? So, what do you mean? Escaped info. What did I break something? So we're gonna escape the quotes, then we're gonna print the escapes. Usability is harder, but I'd likely pick Rust if I don't need C portability. I would too. People have come to think that I just hate Rust. I do. I hate the community. I hate the Rust. I hate the Rust syntax. But the reason that the people that I respect deeply love Rust is because of this. And that frankly includes Mr. Frank, 10X programmer, and Gamozo and Brian Cantrell, the people that are seriously considering avoiding the footguns like this, as opposed to just jumping on the bandwagon. And the last language they coded was JavaScript, and now they want to do promises in a language that's kind of like C. That's why I reach for Go, because Go is a more practical language for applications development than Rust. I would argue that Rust is a lower level language than Go. In fact, I would argue that it goes like this. It goes assembly, C, Rust, Go. Python and the gang, Crystal, whatever. Do you know what I mean? All the interpreted languages. If you're looking for low-level languages, yes, Rust is closer to C++. Yeah. But you would argue that with C too. You have C and then C++. Objective-C, all of those languages that are modifications of C, not C#, by the way. The C# is a fucking idiotic name from Microsoft. It has nothing to do with C. So if they had done, so let's do it again. So it would be assembly, and it would be C, and it would be Rust and or C++, right? And then you would have Go on top of that, because Go has garbage collection. Because Go has garbage collection and all those nice, cushy things. Rust has cushy things too, like promises and stuff that kind of belong at a higher level, but whatever. So that's how I would rank the levels of the languages. That's why when I see people like Gamozo write fuzzers and minimal operating systems in Rust, I don't have a problem with it, because it would be much faster to do that than C. That's the Rust coding that I highly respect. That's the Rust coding that I think you need to learn C to understand and appreciate, which is why I think you should learn C before you learn Rust, personally. But after that, go to town if you want to write that shit in Rust. And I respect those kind of people that are doing microcontrollers and stuff like that in it. Trying to say that Rust is the new Python or better than Go is stupid, because Rust and Go barely overlap. Go as a user level language that happens to be C compatible and compiled down and everything. It is not. It's closer. Go is closer to Python than it is to C. It's supposed to be a modern C, but it's kind of in the middle of those two things. And that's why I love it so much. We'll have Jai Zig, Ode to Mess Around Future. Biography. I haven't read it. No. God, no. I have to finish my other biography first. They want random stuff in their ASM output. They need control to fine tune it. Linux is in C because they need low control. Linux revolves and visualize assembly C outputs. They absolutely do, yeah. Also, Rust unsafe is a footgun. Yes. All guarantees are off for that. And that's why, yeah, right. So if you're starting to write a lot of Rust unsafe, you probably should have wrote that in C. I would say, if you're trying to do shared memory for communication between two things, I don't think Rust is a language anymore. I think at that point you need to start. You should be writing in C. And Brian Cantrell said so publicly in "Is It Time to Code the Operating System in Rust?" in the video. That's what he concludes, and I agree. GCC is not needed. You just use it correctly, right? Go is much faster than Python, nearly as fast as Rust. It depends on what you're doing. I make a big point about comparing speed. I think developer velocity in Go is much faster than Rust, personally. But I have no objective proof of that. I just think it is. Can you make your list of top 5 languages ever made? Python is a good language, but I don't like those lists because they don't have any relevance. They don't don't have any relevance. What are you measuring it based on? Its impact on the world or something? How much, whether it's green or not. Just Rust mem safety and the standard. If that removes its dependency on libc. Yeah, that's interesting. Yeah. All right. So let's try this. So we're trying to get this double quote thing to work out. Right time, but go program runtime is faster. Yes. Yeah. Rust syntax make my eyes bleed. I know. I hate it. I know. There's two things. I wish a smarter person had made Rust. I'm going to put it out there. I wish a smarter person had designed it. I like it. I just hate the syntax. It's so fucking horribly designed as a language. It is. As a language, it sucks. Its compile times take fucking forever. It's slower than C++ for compilation. The one thing you'll hear Gamoza complain about all the time with Rust is how long it takes to compile it, because it's doing all those safety checks for you. I hate that about it. But the other stuff, not so much, not so bad, And the Go runtime is amazing. It is. So anyway, I mean, at least we can talk intelligently about these languages instead of just throwing shit out you heard off Reddit someplace, right? So at least now you can talk about it intelligently. At the end of the day, if you're going to have a debate about these languages, at least talk in specifics about the language and don't just repeat some Reddit or Twitter post. Go compile time is really fucking fast. I would argue it's the fastest compilation time of any language, even faster than C, because they took liberties with like getting rid of macros and seeing you have to put all the imports at the top and stuff. The compiler for Go is fucking genius. Dependency resolution is awesome too. The ideal way to transafe in Rust is to build libs where each lib. I'm kind of getting interested in this conversation. I know we're supposed to be coding C. All right, let's jump back in. That was kind of our break. We kind of took our break in the middle. I'm sorry. I should have been calling this out, but I feel like we've had a break. Let's dive back in. Let's finish our state D quotes without a seg fault. We're going to send two basically character array buffers. One that we loaded up when we scanned, right? So we did a scanf here. Remember this? So we got this data. We should probably put this up here. We don't need that down here. This is like all the printing, right? We're going to need this later. We don't need it right now. So actually, we can do the escape up here too. It makes more sense, right? So let's keep those stuff there. Data transformation, and then here's our data output. We put a little, little thing here. They're not. This is still a side quest. Yeah, you know why? Because look, the book's fucking wrong. It calls this JSON. Since when is this JSON? This is not fucking JSON, boomers. The people who wrote this book are boomers. I love them to death, but they're definitely boomers. This is not JSON. This is JavaScript. I mean, they got single quotes in here, for God's sake. And it says the program can read comment separate data from the command line and then display it in JSON. I mean, seriously, did they not know that that's not JSON? That is like really, really embarrassing for the authors. Catch a virus on an apple. Oh, God. All right. So based on that, we're printing this out. But if we're printing JSON out, look, let me show you why I'm uncomfortable with this. Because when I enter a string, if I put double quotes in it, it's no longer JSON. It's going to break the parsing. This is JavaScript. This is JavaScript. 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 This is JavaScript. Okay, back at it. I could have done this whole thing with a single printf. I could have. Should I? This is like really wasteful. Yeah. All right, I'll do the right thing. I'll do the right thing. God damn it. God damn it. I don't know if that was. It's supposed to snow tomorrow. Did you see that? We have 100%. We actually have a 100% chance of snow tomorrow. Yeah. You want to do something really horrible? What I could do is just make it a string. Let's do that. Yeah, let's do the right thing here. Const equals const. Hell, we could make a string little. Const template equals. Yeah. Sue me for what I'm doing. Forgive me for what I'm doing. Can this even be done? Please tell me I can do this. Am I breaking things? Can you I'm trying to do Go stuff. This is stuff I would do in Go. Char. Am I gonna get shot? Data. God damn it. Don't they have what if I did it as literal? What's the equivalent of backtick and Go? I love that. I think I have to do it as a macro. Don't I have to do it as a macro? Define string. C macro for constant strings. Macros in string constant in C. It doesn't look good. String concatenation, macro string concatenation. I think I can't. I think it, but doesn't. What if I have it wrap the line? There are lots of ways to do it. Yeah, I don't want that. Don't want that. Can you? I guess you could just put a line return there and call it a day. Oh, that's right. I like this one. Let's do that one. That's because they just add each other together, right? Multiple string littles in a row are joined. But wait, the second doesn't include new one. Fuck. Backslash. Inline. What? Can write raw strings? What? C++ 11 and GCC with extensions are interesting. Well, let's try that. Let's try that. I'm going to try it for learning purposes. R string. But do you have to escape stuff? You probably do. Yeah, I'm sure you do. God damn it. It's not as good. It's not as good as confusing the hell out of this. I don't know. I'm keeping what I have because I want to be done. That's pretty sad to know that it doesn't have anything. I mean I'm sincerely sad for C not having it. These multiple print statements are a waste, but whatever. Extra footguns, yes. Yes. We'll just use like the multiple echo statements like you would see in an old school POSIX code. Escaped info. Escaped info. Escaped info. All right, so let's do this. Let's just I'm gonna cheat. I'm gonna cheat because I just want to check. I'm gonna check all my calling, and I'm just gonna say that out. And do I have to dereference it? Now out is a pointer. I've got a segfault, right? Because I can't change the content. What if I do this? If I do out, out 0. Wait, that's a pointer, so it's going to segfault. God damn it. I'm doing it wrong. Are we sure I'm going to be able to change the values? We are, because I defined them as a character array, right? Okay. All right. I'm not going. This is on the stack because it's an array. Yeah. This is on the stack because it's an array. So the pointer that gets passed in, it decays, but it still refers to something that can be changed to writable memory, right? All right. So let's actually test that. So 1, 2. Yeah. So you can modify. Okay, good. I feel happy. C is attracting viewers. I see. Yes, people they like watching the idiot code C. The rusty C coder blow himself up is very fun to watch. It's like it's like watching a train wreck. So oh right. Goddamn. Otherwise we will have a problem, right? Yes, thank you. Let's see if this builds in decode error unsafe unused parameter in. You know what? I know that. All right, so let's do this. Let's say printf received in oh god. Make what? Make okay. A received blah. That doesn't make sense. Oh, it did it. 1, 2, 3. There. It did it. Okay, we're good. Oh, it's a wait. I thought it was a pointer. Why didn't that work? Uh-oh. Received memset escaped info 0 size of escaped info. Nice. Is that the thing that shrinks it? Is that what shrinks it down? That's a cool trick I did not know about. We're kind of getting into advanced stuff there, but we already kind of are. To zero out the buffer. You're talking about after this, right? So I like that. I'm putting it in here just because I don't want to forget it. At the 0 index, that doesn't do it, does it? Does that actually free it? Sorry, just 0. Does this tell me what the best way to free use memory is? And I know we're getting ahead of ourselves, but we're kind of dwindling. We always do. You just use free, but doesn't this also do that? What does this do? So this says set the memory at the pointer location of that to 0 for the size of escaped info. Is used to initialize. Make sure it doesn't have junk in the buffer. Oh. Whoa. Are you telling me that when you allocate an array of memory that there might randomly be a null byte in there someplace? I need to know this. I really need to know this. That's totally true though, right? So when C says, give me 160 characters, there's a very high chance there will be. Oh my God. They don't talk about that in the book at all, and I totally understand where you're coming from. Variable on the stack is uninitialized. Uninitialized. Holy shit. Holy shit. Holy shit. Setting all that on 0 when the first is needed. You are harming the planet. It just takes time. Again, performance, right? If you don't need to wipe your memory clean because you don't know what you're going to be doing it for, right? The info is going to be wiped clean because that's what we're doing right here. We know we're going to be grabbing and wiping clean and sticking a null on the end because we're doing scanf, which is guaranteed to put a null on for us. So that we don't need to do. But escaped info, we need to clean that memory up before we pass it. Info is written by scanf, right? So that ensures that even if there's shit at the end of it, we don't care, right? So if it scans in 20 lines and puts a null at the end, we don't give a shit about the data between 21 and 80, right? It's been allocated. It's there, but we don't care because info is just going to do everything up to 90 equals 0. Wow. What is that about? Escape 160 equals 0. Is that a thing? Should initialize that at first I wrote it. Yeah. You know that K on a C function in Vim normal mode displays a map page for it. K on a C function. Oh, I did not know that. I did not know that. I learned something today. Holy cow. I'm going to do that again. I got to make a thing about that. Set create. We're getting ready. Hopefully this is useful. Press K in Vim to get C func to see man to get man page in C. Yep, that is all. I have to make sure I don't forget about that so people can read it. I did not know that. If it's just a string, then escape 0. Yeah, it is just a string. So, I mean, I've had a lot of people tell me, is that true in Bash? How have I not known that? I have not known this. I have not known this. Are you sure? So far, so good. So far, nothing. Shop. It's only for functions that exist, I guess. Nope. Map file. Nope. Okay. K. I knew a little bit about K, but I did not know. Language is, you know what? Here. Oh my God. I have not been using that. Oh my God. Oh my God. Why haven't I been using that? Why haven't I been using that my whole life? I feel so stupid. I feel so stupid. Don't be me. That's stupid. I just did capital K on a function in Go and it gives me the full documentation. Because apparently capital K in Vim, that's not a VI thing, gives you the docs. Undocumented. I mean, that is so much better than IntelliSense. I have no way even knowing. All right, I have to post this. Oh my FG about Vim K to show docs about everything. It does have to have a man page though or something. I feel so stupid. 2K. I feel so stupid. I have been using Vim for more than 25 years, and I never knew that. People, like, suffice it to say, look, I'm going to tell you right now, the reason you want to learn Linux and Unix is you never know it all. And if you start acting like you know it all, you're a dick. So don't, because there's always going to be something else you're going to learn. And I've learned most of the things on the stream here, sharing my idiocy with everybody else. Hiding a school trick. I mean, look at this. I can do this. I can do K, and I can find out. Like, I can do memset. What does memset do? Oh, here's what it does. Oh my God. I can like pull that up anytime. Oh wait, you missed that. You missed that. Here we go. I'm gonna do it again. Capital K. It pulls up memset. Sigh. I mean, the number of tiny little things that I have learned, as not to mention the major things that I've learned since streaming and having this community around to back me up and make fun of me, has been phenomenal. Get over yourself, accept that you don't know everything, and share what you do know, because there's a chance somebody else is not going to know something like crazy ass easy. Like, I don't know how to unsuspend their terminal, which is Control Q, by the way. You know, there's a bunch of little things. It's cool. To me, it's really amazing because it works on everything. All right, what if we did this? Is this going to work? Nope, that one doesn't work. Include, does this work? Nope, because it's not a C thing. Avoid system data types. Oh God, that is so cool. All right, I love it. So we are done with our C class. We have literally 15 minutes left before we're done. As usual, at the end of these things, we kind of go off the deep end. It's okay. Lots of great, wonderful things coming out of all of this. So I don't accept this. This is just a string, so I'm going to use the shortened method. Escape info equals null. This is to initialize it and be sure that it is cleaned out. Be sure there's nothing bad in mem. After run with key. Yeah, thanks. Because that's the only reason I have to include that one. Yeah. Memset is in string C. I didn't realize it. Do we have string C here? We did. Are we going to use string C? I don't think we are. I don't think we need string C anymore. Is that going to compile? Yeah. Parse geolocation. All right, so this is working. I don't understand why this is wrong, though. Oh, it's printf. Let's do put s. I don't even know if that's going to work. No, it's not, because it's not a thing. I didn't put in a line return. Okay, that's what's up. All right. I think it did work and I didn't see it. Yeah, it did. I'm pretty sure it did. No, it didn't. It didn't. I don't understand. In zero. Why is it blank? Is there something I'm missing here? The format for input is not correct. This is a pointer, and this, I think I need to take the escape to the pointer, no? Something to scanf. This is supposed to be a pointer. So this is Isn't that passing in the pointer? I thought that was passing in the pointer. It's got to be dereferencing. It's a dereferencing problem. Isn't it? I think it's a dereferencing problem. You know? I guess I'm wrong. How does... Okay, but then why... Why isn't it printing it then? I'm sure it's a referencing problem. I just don't know how to understand it. So look, I have allocated 80 characters. Can you do a print it after you do the scanf? See if there's something actually in there. Yeah, what's that? You entered... Whoa. Whoa, so I was doing it wrong. Nope, that's not right. Character pointer. That's so weird. Float some string. You have scan F45. See this, I thought this was string. Yeah, I know, we're gonna look. Maybe it was the control R I put in there. Whatever it is, it's not expected. Yeah, it's not getting it. Now, I can put an S here and it will get it. I know that will work. But that's going to give us a line return, which is fine. This is a bug problem. This is a bug in the book again. What? The input is wrong. It's not matching up. Oh, God, I'm so stupid. Okay, it's time for me to stop streaming now. It's time for me to stop streaming now. I see my error. I see my error. Does everybody else see how stupid I was? Yeah. Yeah, I'm kind of embarrassed. I'm more than a little embarrassed. Yeah. Yeah, there we go. So, yeah, I quit. You were talking about Pagan earlier today. Yep, I was telling about you. So, that feels really stupid. Okay, so we actually passed everything in the way we wanted. And I think we can go do our loop now. So this is actually what we're going to do. We're going to kind of incrementally, I'm going to leave this here so people can understand it. Oops. And we're going to put this sleep in. Anonymous cheers when I die in Dota and when I make a really embarrassing thing at sea. It's always a good sign. There for support. Better for that, yeah. You should see all the money I've got from Anonymous cheer when I die in Dota. It's kind of funny. Speaking of still, we are still going to do it. It's just like so many things. I want to put it under the projects time. I got so much shit going on right now. We're doing Ansible and everything. We're supposed to be done, but I don't want to finish until this is done. So technically we're done. If you have to go at 4, I understand. I'm going to get this to work, and then we'll leave this to be, and then this whole video is going to go up as is into YouTube, and I may or may not chop some things out of it. I probably will just post it raw. If I chop anything out, it'll just be the breaks. But I kind of feel like people might want the breaks because they need to get up and walk around, and they can take their own breaks, obviously. So let's do this. So all we're really doing here is we're saying I want out the value at the position. So this is a pointer. So the first thing we need to do is detect if the value is a quote. So if C equals quote, then just say whatever, right? So let's I'm going to do it and print it out. Actually, no, we can't. You don't need an index. No, you don't. Not for this one. So if that's true, then all we need to do is we need to say out equals, we should probably do in plus plus out plus plus. Can we do commas here? Is the comma operator work here? Yeah. I don't have to. Okay, so, and then we do, and then this just advances out an extra one. That's all we do there. So then we do out equals, and that's going to be tough to do because that is also an escape. And otherwise, we just make out equals C. No, we have to do out. I have to do the index for out. So that would be right. This is that, right? But it's already a pointer. We have plus plus. But it's already a pointer, right? Equals C. All right, the pointer to out, whatever out is pointing to equals whatever the C was. And then we're doing out plus plus inside loop. Okay, so, but these are fine, right? Because these are already numbers, are already pointers. So char is the character. Out equals the pointer, yeah. Value pointed. This is the dereference, yeah. I keep forgetting. That's the syntax for that in Go is a lot more straightforward. Yeah. Honestly, I think that's it. We're gonna get in trouble. Assignment to char from int makes a pointer from integer. Oh shit. So this is actually this. Yeah. And C equals in. Yep, got that one. I think this C equals in. If this is the thing pointed to by C equals this, which should be fine. And it says it's an integer. Okay, well, suggest parentheses around assignment. It's in the loop evaluation. Let's see. Suggested parentheses around assignment used as truth value. Well, that's kind of a warning. So it says, it's saying it likes this because it makes it happy. Oh boy. What'd I do? Miss key. I think it wants this. What are you talking about? C is the garbage on first iteration. So you'd have to override it. You're using an assignment in a Boolean verification. Yeah. Because we wanted to evaluate to 0. The init statement is the first one. Should be in the init statement. You think that should be in there for sure? Because the first iteration is not guaranteed. Oh, right. Because it could be any character at all, right? I see what you're saying. Yeah, same reason we cleared out memory before. Okay. You're using an assignment and Boolean. Yeah, that part I know. You had it in for whatever reason in the second statement. This one we're evaluating because we wanted it to be null. Yeah. So C, the character equals, but that's not gonna iterate it, is it? Guys, as far as that's the one I needed before the for loop. This is what I had originally. So tell me why I can't do that. So I had that originally. This is what throws me off though. So this says the C equals what's pointed to. So are you telling me that this should only happen at the beginning of the for loop? This is never happening again. And I don't see C getting incremented at all. C will always be the first element. It's never updated. So this says that C equals the pointer to in. So if I change the pointer value of whatever is in, then C will be changed. That's what's going on. That's really fucking magical. But I get what you're saying. I'm just not seeing how C gets updated. All right, you can throw C away C and just use in. Well, that's what we were doing originally, and everybody was like, I have no fucking idea what's happening because it's too hard to read. Yeah. So you could change out plus plus in plus plus to out plus plus C equals plus plus in. Yeah. If you want to iterate it with a pointer, just increment and test against C instead, or better yet, just drop C altogether. I've had people go back and forth about whether we should have C in here or not. And I feel like this is acceptable. Yeah. Help me understand. So the thing, I know they're all going to be different, and that's the thing. I actually want to arrive at what's clearest for a beginner. It's wrong now. What I want to know is how C doesn't ever get updated in the loop. C equals. You want to put that in the conditional statement? Yeah, that's crazy. It's definitely wrong. It was fine before. So everybody's got a different way of doing it, and nobody can agree on the best way. Sounds like C. Okay, so this I thought was fine as long as we evaluate that as a Boolean. Which means if I put this like this, it should be fine. How is that wrong? So I'm going to try it. Let's see if it works. Here's your info. I mean, it didn't die, but because of wall. It's fine now. For C equals to N, so C does not equal null. I like that the best in Santis. I like yours the best of all. I like yours the best. And Santis wins. And Santis wins. Yeah. That is, if that works, you definitely win. That is so explicit. I can't stand it. I love it. And but it's not annoyingly explicit. You know what I mean? Init check change. I know about init check change. Yeah. So init check. I love that this actually says, is it null or not, instead of doing it implicitly. I think for beginners, this is the way I want to do it for sure. And then if you want to get magical later than that, fine. Although I think magic is dangerous. I don't like magic. I especially don't like magic in my C. God, you think magic is dangerous in Perl? Put magic shit in C and watch the world collapse, which it has. You know, all those magical C programmers have made Rust popular. That is not the best for beginners. That's what I had, and I don't want to do that. It's super magical, but it's 100%, and it's sexy. It's definitely sexy, but it's so unclear and deadly. I will never code that way. In++ is clearly the most concise. So that says we're just incrementing the... That actually isn't too bad because I can read that. I know what the fuck's going on. That's just incrementing the pointer, right? I like that one too. I really do. So I like that one too. This one is my favorite because it has the init check change. You know you're dealing with a number. It just so happens you already have the variable defined. And it implicitly defined. But I thought you were saying that the initial value was bad, but you already have the initial value because in has already been defined. I see what you're saying. Because of C foot guidance. Yeah. Yep, as I wrote, C variable is not needed at all. Yeah, I know I've noticed it's not needed, but the reason I like this one is it's like, oh, we're going to increment a variable. It just so happens that our variable is already given to us, and it happens to be something that can be incremented because it's a pointer, which is a long int. So I like that. It's the most succinct, but I'm going to put this one clearest. Let's say clear, and then we'll put this one as concise. I like that. That is hands down my favorite because I feel like I understand what's going on. And I think we also need out though. We have to increment out though. Yeah. We could have done that in a separate way, but yeah. Is there a reason for use for instead of while? I think it's because we wanted the initialization and the incrementers as opposed, I mean, you could do the same exact thing in while. Yeah, you definitely could. Yeah, but that one's a little bit too magical for me. I mean, that's some great code. It's just really magical. I don't like it. Yeah, so down here I put does it have to be a pointer in or can it just be in? It's the thing pointed to by in. In is a pointer. So it's like, is the thing pointed to by in something else? The thing pointed in by in goes into the thing pointed in by out. When in is empty. Right. We'll pass in double space in out as there is an in. Yeah, that was an assumption. We did rather than do malloc and all that stuff, we talked about doing that as a solution. But for right now, we're assuming the caller is going to allocate the space properly. I mean, that could be coded. That could be easily coded. I understand. But right now, we're guaranteeing that it's twice the space. Yeah. So assumes terminated with null and out is twice the space. Twice the size. It's just mostly just an exercise here. Will be empty. Oh, I know, absolutely. Yeah, I know. And then that'll have to be freed, and that's a pain in the ass and stuff like that. Yeah. This is not even a part of the exercise. stuff we're doing. The shit that they do is like, first of all, it's not JSON. Secondly, they just throw in a bunch of shit and convert it without any escaping at all. The ending 0 in out is missing. Oh, right. We have to add it. Good, good, good. Thank you. Thank you for that. So out. We need to do that outside of the loop. So we say out equals, that would be a bad error. That would be a very bad error. Right? Goddamn. That's the kind of error that would easily happen in production. Finally. All right, so yeah. You don't have to initialize out in the main function. Why not? Because it's guaranteed to be overwritten with whatever was in the new in thing, right? Yeah, I see what you're saying. Yeah, because it's guaranteed. Yeah, I see. But you have to be sure of that. Yeah. Let's say does not need to be initialized before passing. Compiler will optimize it since it's a single transition unit anyway. Yeah. Yeah. This is cool. This is really good info. I know we're getting really pedantic and having fun with it. Y'all are brilliant, and I appreciate you being here. So okay. I feel so good about this. I feel like I really know what's happening here. Now, does it work? Is the question. Don't forget this. Don't forget this line. Terminate string. That would be really bad if you didn't do that. Right, unit tests, of course. It doesn't even talk about unit tests in the book. Don't forget to terminate. I kind of want to talk about unit testing C, but we're not gonna have time. We did 4 hours and we got through most of the chapters. If this works, we're gonna wrap up today, and I'm gonna go do some other torturous stuff. So get rid of that. And that should be good. Let's test now. I know you guys want to go. The fact of the matter is, what's that? So, something foo here. Yay! I mean, it has tiny little things there, but it works. It works. It works. She said, okay, so let's say, oh, we need this here. This needs a backslash. Some faux thing. There we go. We're done. The dishes are done. Gangsta. It's still fast. Did you see how fast that was? And it's actually right. The book is not. Be careful. Let's say, be careful how you set started. Scan F. So just keep scanning until you're done. I don't know. I like mine better. So we're going to skip this. Latitude, longitude, info. Test drive. We did this. We did it. They called it Geo to JSON. I'm going to change the name just because they did. Parsco, Geo. I don't want people to get lost. It's not JSON, you dummies. It's not JSON. It's JavaScript. Oh, God. That's why I don't want to write a book. I don't want people to yell at me when I get stuff wrong. I'd rather they yell at me here than there. It's in my book. I paid $40 for your book and you're a dumbass. Yeah, I know. It's like, yeah, there's our test case. Hey, should we do make test? Should we do that? Should we do a test? Let's make a test case in our make file. Cause reasons. Test dot phony. What I can't even remember it. Is it like this? I think this is it. This is a Riley book? No. It said for C. It's good though. It's good. It's a good book. Yelling here's ephemeral. Yelling at books is eternal. So that's a perfect way to say it. That is a perfect way. I can get over it from here. Yeah. It's utility builds. Yeah. Let's do dot slash geo to JSON to point some make test missing separator stop line 6. I think I'm probably gonna have to make it. What? Wait, doesn't it need something in front of it? Is it gonna make what shell is it gonna use? Computers are hard and awful at the same time. Life. Head first. Yeah, the author actually commented on it. So tell me here. Oh, it's doing bin sh. Fuck that. How do I change my shell to bash? I don't remember my make syntax. It's been forever. I have both the books. I used it all the time. There. That wasn't too hard. Make test. All right, I feel better now. We could actually do something to actually test the thing. All right, is it O'Reilly? Is the head first Celia or is it O'Reilly? I don't know. It might be actually. I think it might be O'Reilly. Yeah. Okay. So done a number of great things there. I thank you so much. Hell, if you want to, you can do this. You can do JSON and then test. You can just do make, and I'll do it every time. Yup. It seems like it's working. Look at all the estimation it did though. It didn't estimate it right. It made it a float. But still, that's not covered in the book right now. I'll be here all day if we do that. Git dash a chapter 3. Chapter 3. And then what we're gonna do? We're gonna say status git. I don't care about the binaries. I'm gonna get them anyway. Git commit. Add geo to JSON from chapter 3. Git push. If for some crazy reason you want this code of mine, here's the repo. You can go get that. Yes, I saved the binary. I know I am. I knew somebody was going to say something because I was too lazy. Do I need to put a git ignore on everything? You know what though? Somebody's going to see that and they are going to do it. So they're going to be like, why are you doing that? And why are you not making a release? And that's great because I think we need pedantic assholes more. The world needs more. I know. Okay, fine. You happy? Wait, okay, I know. I can hear somebody say you should make a clean rule to get rid of all that shit. And I agree that we should. We have Kit LFS for that. Yes, exactly. Make clean. Boom. Um, at least GeoJSON will be right. The rest is going to be wrong. Oh, so wrong. So, get add dash a. Add better. I think it's fine if we for GeoJSON if we kind of slowly introduce people to make because I don't want to hit them with make all at once. You know, add better make file GeoJSON and get ignore. You know what I mean? I don't really want to slam people with all this stuff in make, but I think it makes sense, lol, to incrementally, you know, say, hey, let's learn a couple new things here in make. Okay, so you can actually run code from make. This is why people use this. People use make all the time as a glorified shell script subroutine thing, and it's super inefficient and wrong, but they do it anyway. But building stuff as we have done with the implicit test rules for building that are built into make, building C code with make is kind of the main thing make was made to do. I'm pretty sure. So this is kind of okay. I think make and C are marriage made in heaven. They always have been, and that's totally fine. Particularly if you're starting getting into dynamic linking and stuff, and that's one of the main reasons make really shines. Get attributes there is always a way to ignore all the binary files and typing the name of the program. That would be awesome. If you, yeah, as Rob is, if you figure that out, please let me know. That would be a great thing to know. Your current make file for this kind of stuff is really good. It works. Yeah. And again, you know, the whole point of make is making things easier, and we're using a bunch of implicit stuff. Another thing that's not completely apparent and that we covered on the first day is that the C flags that I'm using are, which Strager came from Strager by way of a community member. These are the C flags that are being written, and those are something I can change for my entire environment. I'd rather not put those in my make file. So just so people know, that's where those are coming from. Git push, push that up, clear. And you don't have dependencies, so just simply make, and that's all. Yeah. I don't have any dependencies. Actually, make by itself doesn't work. You have to set up an all rule for it. It won't do it if you don't. I don't believe it did when we first started that. Thank you. The polyester. I'm going to go raid somebody, and then I'm going to be back, and I'm going to be doing Ansible. I'm going to be setting up a local VM with Ansible. I'm going to create the VM using Kimu, and then I'm going to be configuring it with Ansible to have the Terraform client on it. And then after that, I'm going to be setting up Terraform to use one of the standard highly used SSH providers to use my host's machine as if it were a server for allocation. And it's pretty intense, crazy ass stuff. We're going to yell at each other. So if you don't want to watch that, that's fine. But if you do want to come back anytime and watch some of the higher end systems operations and, you know, sometimes development stuff going on, that's what we do during the rest of the week. And based on that, I'm going to go ahead and raid. I'm just going to click the raid button. We also drink early on Saturday. We do. Giant bombs, we need a O to me. Techno Tim, oh brother. Should we do Techno Tim? Vampire Survivors. What's Iodime doing? Oh, he's doing hardware stuff. Yeah, let's do Iodime. You know what? Let's find a smaller streamer. The problem is with that is it takes a little bit longer. You guys know what I'm talking about? It does. It takes a little bit longer. I'm going to go and browse the science and tech category. You can turn it out right now. If you're watching YouTube right now, go ahead and turn it off. I'm just going to do some rating, and this will still be left in the video because I'm lazy. So, is he on? Is RW Graham on right now? I don't. Oh, there he is. He is on. Yeah, I have a habit of rating people that. Yeah, yeah. I mean, we can rate him. I kind of want to find a little streamer that's not doing anything. Learning Rust on a D&D character sheet, terminal user interface. Oh, we're totally rating that person. We're totally rating this person. Because I'm rating him on behalf of Frank. Yep. I'm rating him on behalf of Frank. This will be fun. Brandon T. Dev. Please give my best to Brandon. Please give my best to Brandon. Should I tip him off? Should I start following him right now? Should I start following him? Hey, as I said about Rust, I said a lot of good things about Rust today. I want everybody to remember that. Frank, you listening? I said a lot of positive things about Rust today. Okay, bye. Brandon's going to have fun with this. It can help me get over my stigma. Maybe I'll even code Rust in here. Maybe after the C thing, I'll code Rust and say, how would we do all of those exercises in Rust? How about that? How about we do head for C in Rust and we translate all those activities into Rust after this and see how you would do it in Rust and have the one-to-one comparison. I might be up for that in my own free time. I might. I do hate Rust. But I don't hate it for everything. I hate the syntax. It's abysmal. But I would like to try to see what that looks like as a rewrite in Rust. In fact, if you all want to do some Rust, go ahead and do your rewrite. But please make sure you understand C first, okay? I'm sorry, C. I can't let you borrow that. All right. Thanks. Here comes Brandon. Bye.